Okay, welcome to me studying for stats. I have a practice test tomorrow for like units 1 to 4, and I really need to study. It's like the unit that I think it's the hardest, honestly, because it has all of the wording stuff. Like, it's more words. It's not hard, it's just like harder to remember. Like, all the experiment designs, the sampling methods, all of that. I feel like that's just so tedious. Not hard, tedious. And then I feel like I'm fine after that, but I really have to study for this one. So far, I've been doing the Khan Academy, and because at this point I'm not gonna do anything else. Like, it's this or nothing. Like, no, it's not happening. So we're doing experiment designs. I went over randomized block. So it's basically when you have a group. Well, actually, let's start with completely randomized. So completely randomized is basically you have a group and you randomly assign them to 2 or more different treatments plus a control group, and then you compare the results. Or you could just have a group, randomly assign them to like 1 treatment, and then have a control group and then compare results. But that doesn't really make, well, whatever. Okay. And then you have randomized block. The only difference is the same thing as completely randomized, except that before randomly assigning them, you're separating them by a certain variable. So in this case, it's gender. So you would have your students and you would separate them by male and female, and then you would randomly assign them to like 2 treatments and a control group, etc. And then you would compare the results, and then you would do the same thing for the females, and then you would compare the results for both male and female students. So that's randomized block. Now let's continue on with the Khan Academy. So this is basically a watch me study stats, or watch me study for my AP Stat Unit 1 through 4 practice test tomorrow, which counts for a grade. That's amazing. Okay, anyway, let's see. A company wants to study the effectiveness of a new pain relief medicine. They recruit 100 volunteers. Oh no, not this again. I hate when they say volunteers with chronic pain. Each subject takes the new pain relief medicine for a 2-week period and a placebo for another 2-week period. Subjects don't know which pill. Okay, so we have blind. And the order of the pills is randomly assigned for each subject. What in the world did I just read? Okay, a company wants to study the effectiveness of a new pain relief medicine. They recruit 100 volunteers with chronic pain, which makes sense because they want things to be the same as possible. So chronic pain. Okay, each subject takes the new pain relief medicine. Is this match pairs? I think it's match pairs because usually when there's no like random, okay, it's just, yeah, because if you can't draw it, it's match pairs. So each subject takes the new pain relief medicine for a 2-week period. So you have your volunteers, your 100 volunteers, and they're each given what, 2-week period? So they're each given pain relief. They're given a pill for pain relief for 2 weeks and a placebo for another 2 weeks. What does this even make sense? They're not being randomly assigned. Are they being and the order of pills is randomly assigned for each of the order of the pills? What does this? Okay, yeah, it's definitely match pairs because it's so confusing to write. So let's see if we're right. See, yeah, exactly. So here's a good, I love that they actually tell you why. Each subject took both the new medicine. Oh, it's when they both take the treatments. And placebo control. So this study uses match pair design. So match pairs. Okay. So match pairs would be here. Okay, so match pairs is when the subject, or each subject, takes both the treatment, takes both the treatment and the control group. So, a control group can be a placebo. and control group. So each subject takes both the treatment and control group at some point in time. I don't think it could be at the same time, can it? At some point in time, or they switch between takes, or we could say switch betweens. Switch betweens both, between, wow, cannot spell. Switch between, wait, each subject takes both the treatment and control group, or each subject switches between the treatment and control group, taking both of them basically. So, and then you would compare results. Of each subject. Okay. And it's not a completely randomized, because they weren't randomly assigned to one of the treatment groups. They all got it, but the random assignment came with, the random assignment is the order of the pills. So they didn't know, like, it could have been like you had like one subject and then another subject, and they're both the same with chronic pain, but one starts off with the treatment and the other one starts off with the placebo, and then this one takes the placebo after 2 weeks, and then this one can start off with the placebo and then take the treatment after 2 weeks, and then they would, so that they don't know which they're taking, so that it wouldn't affect their it wouldn't have a placebo effect. So it was blind, to prevent placebo effect. So that one person's like results are not influenced by them knowing what treatment they got. Okay, fine. Moving on. Okay, an online retailer wants to study whether more lenient return policies increase purchasing behaviors. They select a random sample of 2,000 customers who have made purchases in the past year. Okay, so what do they do? So they select a random sample of 2,000 customers who have made purchases in the past year. They use a random number generator to select 1,000 customers. Oh no. Okay, so they have a pool of just customers. They have a pool of customers who made, let me write this a little bit better. So they have a pool of customers who made purchases in the past year. So this is like one pool. And out of that pool, they take basically, they take an SRS, like a simple random sample. They select a random sample of 2,000, and then they have 2,000 customers who made purchases in the past year. So, and by the way, it's not literally that this is the actual pool and they just take it from this spot. It's just so you know that there is something being taken out of that. But a simple random sample essentially would be, let's say in blue here, it would just literally be random customers selected from all over the pool, not just like one certain like place in the customer pool, if that makes sense. I just didn't want to be doing like this to show like 2,000 customers. So just for clarification, what did I do wrong this time? Like, why do I have to, there's an undo, redo button. Okay, anyway. 2,000 customers who made purchases in the past year. So they use a random number generator to select 1,000 customer account numbers to assign them, blah, 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 blah. Okay. So after they have the 2,000, so this is our 2,000 customers, we have basically a random assignment. We have a random assignment. Actually, like, I don't know. Okay, so this is a random assignment. The random selects 1,000 customers to assign to a treatment group. So random assignment of 1,000, random assignment of 1,000 to assign to a treatment group. The remaining 1,000 customers assigned to a control group. Oh, wait. Oh, yeah, that's perfect. So this is treatment, and this is a control group. See if you can draw it. It's not matched pairs. Okay, so it's not B, it's not D, because D is a sampling method, not an experiment design. Let's see. It's not C because that's a sampling method. So it's either going to be A or E. And we didn't separate the 2,000 customers in by variable, by gender, or by anything actually. So I'm going to say it's completely randomized. And we're going to see. Okay, perfect. Okay. So what would make it matched pairs is if each subject received the new policy and the control. So that would be matched pairs. And what would make it randomized block if it was subjects were divided into groups based on some other variable. So this is another example of what? Of completely randomized. So another example for completely randomized. Okay, moving on. Researchers at Mississippi State University were studying the impact. Researchers at Mississippi State University were studying the impact of different environmental sounds on ecosystems. For their study, they created 3 similar ecosystems in their lab, containing a variety of insects and plants. They randomly assigned each ecosystem to be exposed to rock music, country music, or a conventional city soundscape. What? Okay, so we have 3 ecosystems. They randomly assigned each ecosystem to be exposed to rock, music, country music, or conventional city soundscape for 2 consecutive weeks. What? So if you can't draw it out, nah. Maybe? This is hard. Okay, at the end of the system, okay. They randomly assigned each ecosystem. Oh, so like, so one would be, how does that work? How do you randomly assign that? Like, I would, okay, if I had a hat, and I flipped it upside down so I could put stuff in it. Ooh, that is not a hat. That's not what a hat looks like. That's definitely not what a hat looks like. I could do better. We're gonna pretend that was better. Actually, do I have any concept of like... Okay, that's good enough. So in the hat, we have like 3 pieces of paper. That doesn't make sense though. One paper says... See, no, that doesn't make sense. Okay, one would be rock music, one would be country, and one would be conventional city. Okay, we're just gonna say city because whatever. So then we put those in the hat. Yes, in the hat because it looks like a box. And we go one by one. So we take, okay, the first ecosystem, we pick a hat, we pick something, and let's say we get like country. So then that would be, so the first ecosystem would be like country. Then we go number 2. Okay, we're gonna pick a what? Any, oh no. Oh my god, they said that they each assign. So instead of assigning the music to the ecosystem, they assign the ecosystem to the music. How does that make sense? Literally, what's the difference? This is so confusing. So, so annoying. Okay, so let's draw a hat. That's totally a hat. So, okay, so we have ecosystem 1, ecosystem 2, ecosystem 3, and they all go into the hat. Whatever. Okay. And then we have 1, 2, 3. We have rock music. We have, what was it? Country music. And then we had conventional or city music, whatever, I don't know. Okay, and then we would go, okay, from rock music, we're gonna pull out of a hat ecosystem 1. So, oh, well, no, let's say we do rock music first, right? Okay, we have rock music. Okay, pick the hat, pick the hat, pick the hat. Do the stuff, right? What am I saying? Do the stuff. Wow, so descriptive. Sorry. I mean, mix the hat, you know, and then pick a hat, and let's say you get 2. Okay, so then rock music gets 2. Ecosystem 2. Perfect. And then you do the same thing. Shake the hat and pick a what? Oh, pick one of the ecosystems, and let's say you get 3. So this is eco 3, and then the last one is obviously eco 1. Okay. So I guess you start with the type of music, and you randomly assign to eco 1, ecosystem 2, and ecosystem 3. I guess. And that is a completely randomized design, I believe, right? It's not right? I think so, right? It's completely randomized. Because it's not a stratified random design, doesn't even make sense. That's because stratified is a sampling method. A matched pairs design, that doesn't even make sense. A randomized block design, okay, let me explain why it doesn't make sense. So it's not matched pairs because each ecosystem is not being paired with all 3 of the music genres. So because of that, it's already not matched pairs. A randomized block design where 3 ecosystems are the blocks. See, that's interesting. What if it is like that? A randomized block design where 3, because look, it says over here, further said they created 3 similar ecosystems. That just comes out of nowhere. 3 ecosystems. But they're not saying, no, I think it's completely randomized, yeah. Okay, let's hope we're right. Okay, great, yeah. So, okay, it's not a randomized block design where 3 ecosystems are the blocks because these are experimental units, not blocks. See, I knew that. Yeah, I knew that, totally. So, yeah, that's what I said. So, these are experimental units. So, I guess, quick note, only experimental units, basically what the subjects, what you're, like, testing conditions on cannot be your blocks. And when blocking is used, treatments are randomly assigned within each single block. So it would have been like, okay, rock music, country, or it would have been like, instead of doing that, it would have just been like, rock, country, and then each one would have ecosystem 1, ecosystem 2, ecosystem 3, and then ecosystem 1, ecosystem 2, ecosystem 3, and then the last one was like what, city conventional. So it would be eco 1, eco 2, eco 3, and that would have been a block. Well, no, that would have been block. Yeah, that would have been block because it was separating by variable. So the variable would have been music, but that doesn't even make sense in context of the problem. But just to give you an idea. Okay. We're going to still continue with this because Sarai needs more practice. What are we even... Oh, this is another example of completely randomized. Can we have some other examples of, like, that's not completely randomized? Because completely randomized is the easy one. Okay. There's another one. So, a psychologist thinks that meditation might be a useful tool for patients trying to lose weight. They design an experiment and recruit volunteers. I hate it when they say recruit volunteers because, okay, by the way, if you didn't know, if they ever talk about volunteers, we can never generalize our results to the population of whatever experimental unit we're studying for, because there were volunteers, and that automatically is kind of like a bias thing. But if they were simply randomly assigned from a population, because usually when there's volunteers, then you randomly assign, but so you start with the population, and then from the population there's volunteers, and then you randomly assign those volunteers. But because you had volunteers, you can't generalize your results to the population anymore. But when you have the population, right, and you go straight to randomly assigning from the population to like your different treatments, then you can generalize your results to the population. I am so sorry for my messy handwriting. I promise that I really have good handwriting. Okay, just not right now because it is 8 p.m. and I still have 5,000 things to do. Okay, so what are we doing again? Okay, they design an experiment. Okay, they design an experiment and recruit volunteers who are all interested in losing weight. Half of the subjects determined at random will attend weekly guided meditations. Okay, so you have the subjects, half of the subjects, let's say we had 100 subjects, and so half of them, 50, were randomly assigned to attend treatment 1. In this case, treatment 1 is the guided meditation sessions. And then half of the and receive access to diet and exercise program. The other half of the subjects will just have access. The 50 will have access to, I guess, treatment 2? Or is treatment 2 the control group? So do they just want to know that, do they want to know, like, the effect of, having the meditation sessions on top of receiving access to a diet exercise program? Yeah, so I think, treatment 2 is just the control group. It's just, so guided meditation sessions plus diet and exercise program. And then the control group is just the diet and exercise program. And then obviously at the end you would compare results. Okay, so compare results. Oh, that they didn't even ask. Wait, this is not what I wanted. It literally brought me to a new session. This is not what we were doing. Okay, we're gonna do this one and then we're gonna go back. So what are they asking? What is the primary purpose of including a group who doesn't attend meditation centers? Oh, that's exactly what we just said. To serve as a control group for comparison. Period. See? I mean, punto y no coma. Because apparently people get offended if you say period these days. They're like, I lose all my respect for you, Sarai. I'm like, you can go ahead and do that. Okay, wait, where are we going? So, experiment. Okay, go back. So now I just say punto y no coma. Because, Hispanics are the first ones to say it. By the way, like, it's a Hispanic thing. It was like, my mom always said, punto, Sarai. Punto. Wait, where am I even going right now? Oh, right here. Perfect. Okay, so let's do more of these. Because these are, I feel like, oh my god, Khan Academy is amazing for stats. Not for calc, but for stats. Okay, so a company wants to study the effectiveness of a new pain relief medicine. Okay, let me just... Actually... Okay, so let me do... This is like a note to self, note to remember. This is an example of completely randomized. This is an example of completely Randomized. See, and the other problem, I just thought we were trying to figure out what type of design it was. I didn't even read the answer choices. Okay. This is another one. Maybe I should use my shapes instead of making my own. Okay, a company wants to study the effectiveness of a new pain relief medicine. Did we not just do this? We did this already, right? I think we did this. Well, we don't have to go back. We could just figure it out. So, okay, half of the 50 male wait. They recruit 100 volunteers who suffer chronic pain. We literally just did this. Half of the 50 males are randomly assigned to the treatment group, and the other half are assigned to the control group. The same method is used to randomly assign half of the, no, we did not just do this. This is actually randomized block because you have basically a group of people and you're separating them by a variable, which is gender. So we have males and then females, and you're saying that you assign half of the 50 females. So it's like 50-50, and then you take 25, 25, 25, 25. So randomized block. Perfect. Okay, next question. Okay, a group of researchers wants to study the effect of listening to music at different volumes on driving reaction times, and they recruit 100 volunteers. While playing music plays... Oh my god, my sisters. Okay. So, where were we? A group of researchers wants to study the effect of listening to music at different volumes on driving reaction times. They recruit 100 volunteers. While music plays in the car at one of two volume levels, each subject encounters a number of signs, some of which require braking, and their reaction times are recorded. What? What does this mean? While music plays in the car at one of two volumes, each subject encounters a number of signs, some of which require braking, and their reaction times are recorded. The subjects... Oh, that makes sense. Okay. The subjects repeat the experiment at the other volume level. The order of the conditions is randomly assigned for each subject. Okay, so essentially, what are we doing? So basically, people are in a car. Beep beep. Actually, isn't it the other way around? Okay, we're gonna pretend that's a car. So in the car, we want to know basically the effect of listening to music at different volumes on driving reaction times. So we have basically 100 volunteers, and while music plays in the car, so we have some music going on here. Wow, we cannot draw music notes. It's amazing. Okay, so there's music playing in the background. Okay, so there's music playing in the background, two levels. So each subject encounters a number of signs. So we have, let me erase the lights, it's not necessary for the, oh my god, what happened? Not my car. There we go. So we have level 1, and this is level 2, we're gonna say. So each subject experiences certain signs that tells them to brake. So I'm literally gonna just say like brake. This is a sign, okay? Some of which require braking, and so it's like, so that they don't know which one, but this is like really what they want to see. Okay, so there's multiple signs, but we're just going to use the brake one. So the subjects repeat the experiment at the other volume level. So they're the same. So they're the same people. Yeah, this is match pairs. Because they're not being randomly assigned. Wait, which reaction times are put in? Yeah, so yeah, they're not being randomly assigned. Like, the level of music is not being randomly assigned to, like, different experimental units. They're both, like, the people here, they're the same people. So at one time, okay, so this is like, let's say like 8 a.m. on a Tuesday. And currently they're listening to level 1, right? But then let's say, Can we please? No, that's not what I meant. How do you delete this? It's a new version, so paste. Okay. And then let's say, now it's 9 a.m. on a Tuesday, and now they're listening to level 2. So they're the same person, and they're going through both treatments, and so because of that, it's going to be matched pairs. Great. Okay, moving on. So this is oh my god, how horrifying. Can we add a shape? How can I add a shape? Shape, square. Okay, and this one, can we make it clear? See, I know how to do this totally. How do I make it thicker? Okay, so this is match pairs. Okay, an insurance company wants to study whether offering incentives for preventive care reduces overall healthcare costs. They select a random sample of 200 of their customers. See, so here's the difference between the one we just did and this one. Here, they took 100 volunteers. The day I can write neatly, oh my god, 100 volunteers. Here, they took a random sample of 200 of their customers. So the customers is already like the population that they pick from, and they just picked an SRS of 200. While here, they literally just took the population, and from the population, there were volunteers who literally, essentially volunteered, and then from there they randomly, well, they didn't randomly assign them, but that's what we mean. Well, it's not randomly assignment, it doesn't matter. But the fact was that there were volunteers, and so we cannot generalize our results for this problem because there were volunteers. But here, on the other hand, we can generalize our results because it's literally coming straight from the population, and then they're being randomly assigned. There's no volunteers going on. Okay, moving on. So which type of experiment design is this? So they use a random number wait, where are we? Oh, so they have 200 customers. 200 customers. They use a random generator to select 100 customer accounts to offer the incentive. So random assignment of 100 customers. We're just going to use the remaining 100. They weren't really randomly assigned. Do we have to mention if it's random assignment here? That doesn't really make sense, right? It's just the remaining 100 customers. So here they offer the incentive for the 100 randomly assigned customers, and then here we're just assigned to a control group, so those who didn't get an incentive. And they just basically, in context, they would compare what? The reduce, compare their healthcare costs, I believe. Cost. And so yeah, this is pretty self-explanatory. So you have 200 customers, you randomly assign 100 customers to an incentive, and then the other ones just get assigned to a control group, so those who didn't get an incentive. And basically what they want to know is if by comparing the healthcare costs, they want to know, okay, those who got an incentive, were their healthcare costs higher than those who didn't get an incentive. And so I think that they want, essentially everybody wants a lower healthcare cost, so basically if an incentive, if these 100 customers get greater healthcare costs then those who didn't get an incentive, then obviously the better choice would be to have no incentive. But if the 100 customers get a lower have a lower healthcare cost overall, that shows that the incentive did cause. We can say it caused. Why isn't it undoing? That shows us that the incentive did cause for an overall less healthcare costs, which is good. So then you would say incentive. Now, again, why are we saying cause? Because it's an experiment, and with experiments, we can prove causation. Okay, moving on. Oh, wait, we didn't even answer the question. So, I just explained. Okay, so essentially, what is this? This is a completely randomized. Why? Because you have it straight from the pool, and you randomly assign them to two different treatments. So this would be what? Treatment. So this would just simply be the treatment. And then this would be control group, but the whole thing is like the no incentive. Also, it's important when you're actually designing an experiment. I'm just simply saying random assignment, but you actually have to specify how you randomly assign your experimental units when you're designing an experiment, by the way. But we're not getting into that right now. And then these are your experimental units, or you can call them your subjects. So here are your parameters. Well, not parameters. Jesus, do not use that word. Parameters is literally, it means so much. A statistic. Okay, it's statistics. Control group, treatment, compare. It's kind of your template. Randomly assign. Okay, perfect. And this is an example of what? Completely randomized. Okay. And it's not block because we didn't separate the 200 customers by variable. So we could have separated the 200 customers by gender, and it could have just been, okay, 200 customers, take the male ones, take the female ones, and then from there we would randomly assign 100 of them to the incentive, and then the other one would be the control group, so no incentive, and then compare results. And, same thing, incentive, control group, and then compare. This would have been a block. What is it? A randomized block. A matched pair. I don't think we could do. A matched pair would be a matched pair. It wouldn't make sense to do a matched pair with this one because it's, I don't know, like it's not the same. You don't really have the same like conditions. Like maybe you could take like 2 years, so you could take 200 customers, right? And you can do like 1 year, you have them take the incentive, and then the second year you have them take the you have them have no incentive, no group really, the control group, and then you would compare the results. So the 200 customers, you would have them like, this is 1 year, and then the second year, and you would just compare the results. That would be matched pairs. Both of them, I mean, all the 200 customers taking both of the treatments. So one one is the incentive and the other one is a control group. They don't have to be at the same time, so that's why I'm saying, like, okay, 1 year, and then see what the healthcare costs are for that, and then do the second year, and then see what the healthcare costs are for that, and then compare results. I think that would be a matched pair. This would be randomized block, matched pair, and completely randomized. Okay, moving on. We're gonna do a few more, and then we're gonna move to considerations, like we were doing earlier. Okay, Estelle's cornfield is divided into 6 regions. Oh no. She wants to know if a new pesticide is as effective as the pesticide she currently uses. She randomly assigns each of the 6 regions to either the new or current pesticide for a month. What does this even mean? Okay, wait. Estelle's cornfield is divided into 6 regions. Okay, so we have a cornfield, guys. Hold on, let me go in here. So we have a cornfield. Ain't this pretty? Wow, we can't even draw a square. That's embarrassing. Okay, cornfield. And it's divided into 6 regions. So she wants to know if a new pesticide is as effective as that pesticide that she currently uses. So she randomly assigns each of the 6 regions to either the new or the current pesticide for a month, and she'll compare the effectiveness of the pesticides. So this kind of reminds me of the hat and music and ecosystem problem. So interesting. So I know that we have the pesticide, the new pesticide, which is the treatment, and then we have the old pesticide, which is the control group. And they're being randomly assigned to... That doesn't make sense. I feel like it's better to word that the 6 regions are being randomly assigned to a treatment. So I would say 6 regions randomly assigned. Actually, 6 regions randomly assigned. What is it? Okay, wait. Oh, not this. I hate this. Oh my god. Okay. Let's think. I think it's randomized block, because if you think about it, it's the 6 regions individually, so like 1, 2, 3, 4, 5, 6, and they're being randomly assigned. But that doesn't make sense. This is so confusing. Okay, let's draw the hat. So we have the hat. Okay, we have a few pieces of paper here. So the new and the old are going into the hat. And so we have, let's say this is 1, this is 2, this is 3, region 4, region 5, region 6. Okay, so we're currently in region 1, and we're like, okay, which pesticide am I going to assign it to? I'm gonna go to the hat, I'm gonna shake the hat, and then once I shake the hat, I'm gonna pick one, and let's say, oop, I got old. Okay, so then this one gets old. Okay, let's say I'm in number 2 now, region number 2, and I want to know, okay, what treatment am I going to have to assign this, or what treatment is going to be assigned to region 2? I'm going to shake the hat, and let's say I shake the hat and I pick one, and I get, not this again, and I get old again. Okay, well then, this is old again. And let's say I'm finally in region 3, and I want to know which treatment I'm going to assign to this region. Okay, I'm going to shake the hat, and let's say I shake the hat, and then I pick one, and I get new. Okay, well, great. This is treatment 3, this is new. So how in the world am I supposed to draw that? Because I don't know. So I have, because these are 2 things, so like the treatment, but usually the treatments are not like that. They're not being, okay, they're not each being assigned a treatment. They're each being assigned only one treatment. So I'm assuming that we have our we have our one region. No, not one region. What is it called? A farm. We have a farm. Cornfield. A cornfield, which is separated by 6 regions. Region 1, Region 2, Region 3, Region 4, Region 5, Region 6. And then each region, that doesn't make sense, is randomly assigned a treatment. Or is not randomly assigned a treatment. So like Region 3 would be randomly assigned a treatment or a control group. That doesn't make sense though, because they're not both assigned. It's not like the region can be separated. Huh. I have no idea. This is hard. Matched pair. It's not matched pair. Is it matched pair? No, right? Randomly either the new or current. Or maybe. But the thing is that if it's the okay, these can't be the blocks, can they? So it's either these being the blocks or the pesticides being the blocks. So we have the pesticides.
I'm not talking to you. I'm talking to Dad.
Pesticides. Oh my god. Okay. Pesticides, and then okay. I took a little lunch break. It's 9:05 p.m. now. So she randomly assigns each of the 6 regions to either the new or current pesticide for a month, and she compared the effectiveness of the pesticides. What does this even mean? Okay, so these are the regions. So we can have the regions as blocks, or we can have the pesticide. How do you even spell that again? Pesticides as blocks. And then each block gets assigned a treatment. That doesn't make sense. So I feel like it's a randomized where the 6 regions are the blocks. No, it's a randomized design where the pesticides are the blocks. No, what in the world is going on? Oh, if you can't draw it, it's matched pair. It can't be completely random. Wait, what if it is completely Wow, this one really fooled me. Are you kidding? How does this even... Okay, I need to explain it to me, please. The 6 regions were each randomly assigned to either the treatment... Oh, so it's... Oh, that's interesting. So the 6 regions, we had to think of them as experimental units. So like it would have been, it's like saying, okay, 6 people and whatever. So it's just 6 regions, and they were randomly assigned to either an incentive or wait, not an incentive. What is it again? To treatment. Oh, the new pesticide. And the old pesticide. Hopefully we spelled that right. And then you would compare results. Okay, that makes sense. See, why couldn't I just think of that? Like, what's wrong with me? This was a really interesting one. Because I was thinking more like, oh, well then, if 6 isn't that divided, like, whatever, like, you know. So it's completely randomized. That's so interesting. So, example is completely randomized. Okay. Matched pairs, there are no pairs involved. These are different treatments. These are experimental units, not blocks. Treatments are assigned because they are experimental units. Okay. Let's try one more. A team of psychologists was curious if omega-3 fatty acid supplements could help treat depression in adolescents. They recruited 50 adolescents with varying levels of depression to participate in an experiment. The researchers randomly assigned each subject to take, so we have 50 adolescents. Each randomly assigned to take either an omega-3 supplement or a placebo daily. So, omega-3 supplement or a placebo daily. So this is what treatment. This is the treatment. This is the control. I can't even spell that. What? Are you kidding me? Why is this thing slow? Control group. And then you would compare. Oh my god. Depression levels. Oh, wait, no, I didn't mean to move on. You know what, fine, let's just move on. Design considerations. Okay, what is the main reason for randomly assigning the subject? Well, it's not really. Random assignment, was it half of them? Each subject to take either random assignment. So I would like to say like 25, because you want things to be as equal as possible. So the question is, what is the main reason for this random assignment over here? To reduce the impact of sampling variability. I guess. To identify confounding variables? No. To create groups that are as similar as possible, so the main difference between the group is the treatment. Kind of. To control against non-response? No. To ensure both subjects and researchers are blind? No. So it's either between A or C. So to create groups that are similar as possible, so the main difference between the groups is the treatment. Isn't that mostly kind of like the reason for a matched pair design? To reduce the impact of sampling variability. So how the samples vary. I feel like that's good. But at the same time, reducing sampling variability, doesn't that create similar groups as possible? To create groups that are as similar as possible. So the main difference between the groups is the treatment. I don't know, A or C. To reduce the impact of sampling variability. Because if you have 30 random samples, like if you have more adolescents getting the treatment than the placebo, doesn't that reduce the impact of sampling variability? What does that even mean? Sampling variability. So the way it differs. So how the samples differ. So reducing how the sample differs. So we want to really have the closest possible samples that we can have, and that's what C is saying, so that they are similar as possible, so the main difference between the groups is the treatment. So what in the world? A or C? I don't know. To reduce the impact of sampling variability, or to create groups that are as similar as possible, so that the main difference between the groups is treatments. To reduce the impact of sampling variability, or to create groups that are similar, to reduce the impact of sampling variability. I feel like A is the more statistical answer, and C makes total sense though. To reduce the impact of sampling variability, random assignment is used to reduce bias. Maybe it's C. To create groups that are similar as possible is the main difference. But does a random assignment necessarily mean that groups are similar as possible? Isn't it more representative? Not similar, but more representative. I don't know. To reduce the impact of sampling variability. I don't know. Let's just guess. Oh, okay, great. Let's see. Okay, the goal of random assignment is to roughly balance other variables, such as age, gender, depression level, and so on. Right, so it's more representative. Okay. between the treatment groups. This way, the main difference between the groups is the omega-3 supplement, so we can make comparisons. Sampling variability is one of the multiple reasons why these 50 adolescents may not represent the entire population. It does not address sampling variability. Okay. Okay, so sampling variability is one of the multiple reasons why these 50 adolescents may not represent the entire population. Sampling variability. Let's search up the definition for that. Is how much an estimate varies between samples. Huh? What? How much an estimate varies between samples. Oh, it's like if you take multiple samples, that would be your sampling variability. So how each of those samples vary. Kind of, right? Is used often to determine the structure of data for analysis. For example, principal component analysis analyzes differences between the sampling variability of specific measures. I have no idea what that even means. Okay, sampling versus the fact that the mean will vary from one sample to the next. So maybe that talks to, okay, and right, so that speaks to how, that speaks to the possibility of the 50 adolescents not being representative of the entire population because of sampling variability. Like, they could be, the samples could be different from each sample taken, right? So, like, the, whatever you're trying to look for, it could be different. Okay, whatever, yeah, right? Yeah, I think we're gonna go with that, sure. Let's move on. So, I guess it's kind of like a note. So, random assignment, the usefulness for that is to ensure the most similarity, to ensure the most possible, is this even English, the most possible similarities, okay, to ensure constant, it doesn't even a word, ensure, to balance out, no, I can't even, okay, sorry, you can make up your own definition, come on. So random assignment, the purpose is to improve or to better the similarities between all the variables in the experiment, to make the experiment more constant. So make the experiment more constant so that the only differences would be due to the results and not other confounding variables. So in essence, random assignment just limits confounding variables. So random assignment limits confounding variables. And back to another point of sampling variability. Sampling variability is basically as many samples you take, you're going to get a different, like whatever parameter you're looking for, you're going to get a different answer. And so that speaks to how it may be possible that your sample may not be representative of the population. Okay, moving on. So this is, Sadie is redesigning her company's website. She wants to carry out an experiment that involves randomly assigning visitors to either the existing design or the new design. Oh, I love this one. Okay, a user's experience is slightly different depending on what type of device they use. So Sadie wants to use a randomized block design. How should Sadie form the blocks? Oh, this is a very nice one. Okay. So, let's look into this. So, is redesigning her company's website. She wants to carry out an experiment that involves randomly assigning visitors. We're okay, so we're assigning visitors. Okay, to either the existing design or the new design. But she wants to carry a randomized block design. So meaning she's separating the visitors into two variables, which we don't know yet because I haven't read the answer choices. And then from there, she's randomly assigning them to either the new design or the new website, or the existing design. New design, existing design. And then she's comparing, what is she comparing? She wants to carry a user experience slightly different than yours. Compare user experience, compare user experience, and then compare user experience again, or compare both user experience in terms of the blocks that we made, which are the boxes. Oh, and we don't need to see the answer choices, I think, because it says that depending on what type of device, mobile or desktop. So this would be mobile or desktop. There we go. Because we're trying to find, okay, visitors who are in mobile and visitors who are on desktop, and they both get, you know, their thing, their design. Okay. So both state and the user should be kept blind. Using in one block should see the new design. No. Each user should be randomly assigned to a block. Users within each block should all use different types of devices from each other. Users within each block should use the same type of device as each other, right? So this is block 1. So just to kind of reiterate. So, okay. This would be block 1. This would be block 2. And then this is a treatment. This is a control group. Treatment. Design. Control group is the existing design. And we're randomly, what's happening here is a random assignment. Random assignment. So answer choice E says the users within each block, so block 1 and block 2 should use the same type of device as each other. So I think that's the one. Users in one block should see the new design. There we go. I just want to explore the other traces. So users in one block should see the new design, while subjects in the other block should see the existing design. No, because they want to test both of them. That would only be making like one treatment. Okay. So this was a beautiful, I love this problem. Okay, so this one was, it was an example of randomized block. Okay. An experiment involving a new pain relief medication involves subjects being randomly assigned to one of 2 treatment groups. Okay. So we have subjects, and they're being assigned to one of 2 treatment groups. Subjects in group 1 will take a daily dose of a new medication. Oh, now I remember. So instead of like, instead of doing this and saying random assignment, you would actually do like group 1, and then this would be like your random assignment, and group 2, random assignment, and then you would do like, you would apply your treatment. So treatment 1, it's just another way to write it. We could write it as this also, but yeah. So then what treatment 2, treatment 1, treatment 2, and then you would write how many people there were in terms of this. So if here were 100, you would want to do 50, and here you would want to do 50. And then you would do like 25, 25, 25, 25. Just to have numbers, nice. Okay, but back to the problem. So subjects in one group will take a daily dose of the new medication. So treatment 1 is a new medication. We'll take an existing medication. All subjects will check in with the doctor every week to report their symptoms or any side effects. So I guess we're comparing health status. Or comparing comparing health status based on the treatment. So like let's say there were 100, right, and treatment 1 would be 50. Well, wait. Nope, this is wrong. So random assigned to group 1, random assigned to group 2. Yeah, no. So this would be different type. It's just group 1 would be treatment 1, and group 2 would be treatment 2, and then still the same 50. You're just showing the random assignment here. It's this part here, it's the same thing. Okay, anyway, my bad. So where were we? So, okay, so this is 100, this is 50, this is 50. Then let's say the 50 people who took the new medication are saying that, their health, like, they experienced no side effects and no symptoms, while the 50 people who took the existing medication did experience health side effects and symptoms more than, or at all, or more than the 50 people in treatment 1 or in group 1, then you can conclude right here that people who took treatment 1 had better health status than people who took treatment 2. Okay, but the question is, all subjects, blah, blah, blah. So what does it mean for this experiment to be double-blind? So double-blind means that both the researcher and the experimental units are blind to who gets what treatment. So, yeah, so both the subjects and the doctors are working taking which medication. Okay, just wanted to write that down. Okay, let's continue. I don't really want to spend too much time because there's a bunch of other stuff we have to go over. So this is an example of, this is just completely randomized. Okay. Okay, so let's read these. So conclusions in observational studies versus experiments. Okay. So Rashonda was curious if students in her class would complete a maze faster if fast-paced music was playing in the background. She randomly assigned each student in her class to one of 3 groups. How many students does she have in her class? Okay, it doesn't matter. So students, she has her students, and she randomly assigns them to one of 3 groups. So fast-paced music, slow-paced music, or no music, which is the control group. Okay, and here is the random assignment. Okay. She timed each student as they individually completed a maze with their corresponding music in the background. Students who worked with fast-paced music on average completed the maze significantly faster than students in other groups. So, the results, so here, whoops, can we please get out of here? If I don't get out. Okay. So then, what? You would compare results or compare results or like who completed the maze faster. Okay, who completed the maze faster? So that's what the experiment design looks like, and this is pretty sure it's a block, a randomized block, or is it a randomized block? Oh, this is just like the hard one that we did. I don't know. Randomized block or completely randomized? We're taking students and when we're assigning them a treatment. I don't think it's randomized block. I just think it's completely randomized. Because we're taking straight out of the population and we're taking a sample from each. Well, not a sample from, random assignment. And then assigning them to a treatment. Right. These are not blocks. Right? I believe these are not blocks. Yeah. Okay. Completely randomized. Okay, so now the question is, can we conclude that the fast-paced music caused her classmates to finish the maze faster? Why? So I like to kind of go over what's cause. I mean, what can make you to cause something? So you can only prove causation if it's an experiment. So let me write that. If it's an experiment, you can prove causation. Now for this, you would want to know what qualifies for an experiment. So what qualifies for an experiment would be, one, there has to be a random assignment of variables. What is going on? Okay, random assignment of variables. I had a list, actually. Hold on, let me look at my stat notes. It's gonna wait for a few minutes. We're gonna wait for a few minutes. Okay. Nope, they're down here. I think they're in my Unit 2 homework. Okay. Or maybe Unit 3. Not Unit 3, Chapter 3. Here it is. Okay. So, principles of experimental design. So one is random assignment, use chance to assign experiment units to treatments. Okay. So we have random assignment, we have comparison. So we obviously have to compare results. So that's one thing. So we have, what is going on with this thing? It doesn't write right. It has to be able to be replicated, right? So use enough experimental units in each group so that any differences in the effects of the treatments can be distinguished from chance differences between the groups. Oh, see, I didn't understand that quite well back in the beginning of the year, but now that I did hypotheses tests and I had to do like the conditions where the sample size has to be greater than 10% of the population, that makes so much more sense now, because when you're trying to figure out if a result is significantly statistically significant, you have to make sure that the sample size is actually great enough that it's kind of that if that in which it kind of, how do I say this, in which it prevents the results, it prevents people from saying, okay, your sample size is really small, so that could have, affected the chances between the two different groups, or the results between the two different groups, because sample size does affect the results. So as long as you have a sample size greater than like 10% of the population, kind of, sometimes, depending, then you could say that, your results are more, there's a better, how do I say this? There's a better chance your results are more accurate. So that makes so much more sense. So replication, why did I write replicated? Oh, results could be replicated. Yeah, so results could be replicated. So we could have big enough sample size. And we go over this like in hypothesis significance tests later. They have to be completely randomized. So note that every experimental design is completely randomized. Like if you take a look back at our notes from the beginning, let me go and show. Over here, right? So if you take a look at the block, okay. The first one is a randomized block design, and the second one is a completely randomized design. So the difference between it is that the basis for each experimental design is a completely randomized design. So if you can see, the only difference between completely randomized and a randomized block is that the randomized block just has an extra step, which is this orange step right here. And that's it. The rest of it, all of this stuff right over here, is completely randomized. So in a matched pair is completely randomized too. So every design is completely randomized. It's just sometimes you have an extra step. So in randomized block, you just separate the group into different variables, and then you do a completely randomized design, which is this stuff over here. Okay. So that's why it has to be completely randomized. Okay. Okay, so they have to have completely randomized, meaning that the treatments are assigned to all the experimental units completely by chance. There has to be a control group. Well, okay, so there has to be a control group. Okay, there has to be a control group. I can't even spell. Control group. So it has to be a control group, and that could either be, sometimes it's mentioned as a treatment, like treatment 2, where it's saying, oh, somebody else, so, and then the rest of them took like a treatment 2 with no medication, and then the treatment 1 would be with medication. So treatment 2 would be the control group. So A control group can also be a placebo. So it could be, you know, something that just kind of cancels out the treatment one. So like a pill, right? We did one of those. So the treatment one would be the pill, and then the control group would be placebo. Okay, double blind spreading through subjects. So completely randomized, and it has to have a control group. There's a difference between control group and control. So control group is, you know, having that treatment that you can use to compare results with, and then control is kind of controlling confounding variables. So something that would control confounding variables would be random assignment, right? So really making sure that everything in your experiment is as constant as possible. That is what control is. So keep other variables that might affect the response the same for all groups. So if you have an experiment that they're telling you to design, and you have the choice to design it, you might want to look at any possible confounding variables. Like, let's say you're trying to find, I don't know, like, let's say you're trying to find, let's look at one of those block designs we did. Randomized block, right? So we had visitors, mobile, and what? Desktop. So we compared user experience in terms of blocks. So the reason we did this is because mobile and desktop could actually be confounding variables. They could have explained, or they could have been what caused or affected the user experience. So because this could be a confounding variable, it could be something that affected the user experience, we made them into blocks. So instead of doing visitors and then assigning them to, instead of doing this, right, visitors, and then just randomly assigning them to the new design and the old design and then comparing results, we did the block, because we could have said, okay, visitors who went to the new design had a better user experience, but that could have been affected by the device that they were using while being on the new site. So because of that, we want to make them into variables so that now we can say, okay, we can compare user experience in both devices and then compare those user experience together. So that's what, so this experiment basically holds a lot of control. So that's also what makes it an experiment. Bless you, baby. Okay, so that's an example of control. Perfect. And I think that's pretty much it. So yeah, so random assignment, compare results, it should be replicated, completely randomized, control group, and control. So wait, that was all just to answer this question. So we're trying to look for these things in this problem. So let's do that. So we're trying to was curious if students in her class, didn't we actually, yeah, so let's look at our design. So there is random assignment, we covered that. So there is random assignment, that's the green right here. There is also the comparison of results, who completed the maze more faster, so that happened. Can it be replicated? So is the sample size long enough? Well, we don't really know the sample size, so we're just gonna, I don't know, we're gonna leave that for now. Completely randomized, yes, we have a completely randomized assignment. So that happened. That's this here, so randomly assigned to treatments. Do we have a control group? Yes, we do. That is this one over here. This is a control group. And do we have control? Well, there's not really, there's no need. There's not really need for control, or maybe there is. Because this one was right. Is there need for control? Would have this been better as a block design? We could have divided by students. Not really, because fast-paced music, I don't really feel like, we can't do like students and then male and female and then fast-paced music. I mean, that's not necessary. So I think there is enough control. There was no need for block design, right? Okay, and then replicated long, oh, that's actually one of the sample size was too small. I'm not sure. So, okay, yes, so can we conclude that the fast-paced music caused her classmates to finish the maze faster? Yes, because the study included each student in her class, so that's not a reason. because the study could have been an observational study which included each student in her class, and not have a random assignment, and it would still include each student in class. So, but that's not a reason to conclude causation. Okay. Second one, yes, because the students were randomly selected. Well, yeah, that's one of the requirements for experiments, so we're gonna leave that there. Yes, because the students were randomly assigned to treatment and control groups. That's also one of the requirements for experiments. Not necessarily because the sample size was too small, not necessarily because this was an experiment. So it's not E, because it definitely was an experiment. It's just that maybe this here is like caveat. I don't know. Is the sample size too small? They didn't even give us a sample size. They just said if her students in her class would complete a maze faster. Her classmates. Well, yeah, it's talking about causation with her classmates. We're not really generalizing to the whole population of students, so I don't know. So it could be A, it could be D. A because the study included, no, I mean not A. It could be B, or it could be D, or it could be C. B, C, D. So yes, because the students were randomly selected. Yes, because the students were randomly assigned to treatment and control groups. That's better. Or not necessarily because the sample size was too small. Okay, I'm gonna go with C, but it could possibly be D because it didn't even tell us the sample size. And a class is usually like 20 students, and usually you want like 10% of the population of students, or like at least 30. I don't know, let's see. Okay. So since we're making, okay, let's look at the reason why it's not, what was it, A, B, C, D, why it's not D. So since we're making conclusions about her classmates, see, I said that it's not generalizing to her entire population, so the sample size doesn't really matter as much. And it's just about her classmates. See, I said that. We can literally loop back. That's literally what I said. Since we're making conclusions about her classmates and the study involved all of her classmates, sample size is irrelevant in this context. Exactly! Tell me that I did not say that. I did say that. Exactly. I was like, yes, that's exactly what I said. We're totally right. Okay, right. Good. I'm really proud of myself for this one. So, yes, because the students were randomly assigned to treatment and control group. Okay, random assignment to treatment control makes the study an experiment so we can make casual conclusions. Randomly selected. The students were randomly assigned, but they weren't randomly selected. Oh, I didn't catch that one. Okay, the students were randomly assigned, but they weren't randomly selected. Oh, I like that. Wait, that's interesting. Wait, so they weren't, okay, they were randomly assigned to obviously different treatments, so different music types. So fast-paced, slow-paced, and no music, but they weren't randomly selected. Oh, okay. Okay. Random assignment is good. Randomly selected. So they don't have to be randomly selected, but they have to have random assignment. But they don't have to be randomly selected to be an experiment. Okay, so caveat. So groups don't have to be randomly selected in order to be part of an experiment. But they do have to be randomly assigned. Interesting. So groups don't have to be randomly selected, because that does make sense, right? Because in other problems we had volunteers. Those volunteers, they weren't randomly selected. They were volunteers, right? But they do have to be randomly assigned in order to be an experiment. So just because they weren't randomly selected doesn't mean that it's not an experiment, but they do have to be randomly assigned. But because they weren't randomly selected, that may tell us that we can't generalize our conclusions to the entire population, which in this context makes sense, because we can't, again, it says that since we are only generalizing our conclusions to that class, to that group of students, right, to that group, the sample size is irrelevant. So because for that same reasoning, when we have volunteers and we randomly assign them and we have a conclusion and we can say, oh, this caused this, we can say that, but we can only generalize that to the volunteers to the group who volunteered, right? We can't say that, oh, like the whole population of New Yorkers, or this caused this, and how do I phrase it? Like we have a group of New Yorkers, right? And not a group of New Yorkers. We have like a select group of, oh, you know what? Okay. We have a select group, not a select. We have like 20 volunteers of bikers, right? 20 volunteers of bikers. And we say, okay, this pill, treatment 1 is 1 pill. Let me just write it down. Jesus, why can I never talk? I always have to draw everything. Like, I need to get my life together. Or my thoughts together. Okay, we have, like, let's say we have 100 bikers, and they were volunteers. So they weren't randomly selected, but they were randomly assigned to treatment. So treatment 1, and then the control group. And then we compare results and we say, okay, we say that people, let's say 50 bikers were assigned to treatment 1 and the rest were assigned to the control group. We're going to say that the 50 bikers who were assigned to treatment 1 had better, let's say, heart rate, or actually weight loss, because treatment 1, let's say it's like a weight loss pill or something. Weight loss pill. And then this is like a placebo, right? A placebo. And then 100 bikers, volunteers can be with the same weight. So everything is the same. So 100 biker volunteers with the same weight. 50 were randomly assigned to treatment 1, which is a weight loss pill, and then the rest were assigned to a control group, which was a placebo. It was blind, they didn't know, blah, blah, blah. Okay, then they compare results, and then they say the 50 who were assigned to treatment 1 lost more weight, or treatment 1 caused more weight loss for the bikers than, we could say, then, not a placebo, maybe we can say like the regular, like an existing pill, like an existing weight loss pill that they were already taking. So treatment 1, so let's say treatment 1 caused more weight loss. This is not writing and it's annoying. Weight loss for bikers than treatment 2. So the new weight loss pill caused more weight loss for bikers than the existing pill. So, but here's the thing, because our group was not, why did I write a hashtag? Like, what am I thinking? Not equal to, was not equal, wow, what is wrong with me? I cannot, I'm like in, like my brain is in Python right now. Not equal to, I mean, it's, yeah, not equal to, not the same. What am I saying? Not randomly selected. Okay, like, so I get to the point, right? Okay, so because our group wasn't randomly selected, but it was randomly assigned though. This is an experiment only because the group was randomly assigned. If it wasn't randomly assigned, it would not be an experiment. But here's the thing. Because they weren't randomly selected, and how do you know that? Because they were volunteers. This result, like this answer right here, can only be applied to those volunteers in the sample. Look at me making my own example. In the sample. And so we can't say, this is literally not even writing, like volunteers. We can only generalize these results to the volunteers in the sample, and we can't say, or the 100 bikers, right? The 100 bikers. So we can say that in the 100 bikers, treatment 1 caused more weight loss than treatment 2. But we can't say that treatment 1 causes more weight loss for the whole population of bikers, like for all bikers, than treatment 2. We can't say that because they were randomly selected. If they were randomly selected, did I say were? Okay. We can't say that because they weren't randomly selected. But if they were randomly selected, so what would that look like? That would be if we have a population of bikers, of all the bikers, right? And if you remember, you would kind of take an SRS or like a sample from the population, and that would be like your group. So that would be what, like, right, your 100 bikers, and then you would randomly assign 50 and 50, etc. So that would be what randomly selected looks like. If they were randomly selected, then you could generalize your you could generalize, let me write it, so you could generalize your results to the population of bikers if it was randomly selected. So this means randomly selected. This is not randomly selected. What they did here is that they took what this looks like over here. Let me show you real quick. New color. This is the population of bikers, and they literally just whoever wanted, how do I draw this differently? Yeah, it's the same thing, like drawing, but it's just the fact that it's not random. So people just, these were just 100 bikers who volunteered. That's the key word. Volunteered here is 100 bikers who were randomly selected. So when you see that the word volunteer, and then they're asking you, can this result be generalized to the entire population? Be like, no, because the group wasn't randomly selected. You can only generalize your results to the entire population if the group was randomly selected. So that means you have a group of bikers and you take a random sample of those bikers. It's not you have a group of bikers and then whoever wants to volunteer, you choose, okay? A survey over 7,000 randomly selected employees in 15 nations recently showed that employees who work in a digital works... Oh, Jesus. I'm so tired. 7,000 randomly selected employees in 15 recently showed that employees who work in a digital workplace tended to be happier than those who don't work in a digital workplace. Can we conclude that the working... No. This was an experiment. This wasn't an experiment because randomly selected, but there was no random assignment. Yeah. So this was an observational study since employees were not randomly assigned to a workplace, so we can't say that the working in a digital workplace necessarily caused the employees to be happier. Okay. Jillian has been updating the design of a media streaming website. She wonders, I love these website problems. It's so relatable. Okay. She wonders if users will spend more time on the site. Oh my god. Stop it, because I'm gonna cry. Because this is perfect, because it literally combines my hobbies, data science and web development. So like, let's say I want to build a website, or like I'm building a website, I'm developing a website, and I want to like see which one's a better design, and I can use my data science skills to figure that out. Oh my god, with my web development skills. Oh my god, stop, I'm gonna cry. Okay, she wonders if users will spend more time on the site with the new design, so she designs a study. She starts with a random sample of 1,000 users and randomly assigns half of them. Okay, so we have 1,000 users, and she randomly assigns half of them, so that's 500, to the old design, and the rest of them is the new design. Okay, after a week, she notices user with new design spends a fairly longer as blah blah blah. So compare. So new design users who use new design spend longer on this site. If you think about it, that's not, you can't say that's a good thing or a bad thing, because they could be spending longer on the site trying to figure out how to navigate it, or longer on the site trying to figure out how, or because they're entertained. So you don't even know, like, you're gonna have to really, I don't know. Okay, what are we even doing again? So, okay, 1,000 users. It is important to note, I'm gonna start writing this so you get it. So we have sample, not a sample, we have a pool of of users, and it says that she starts with a random sample of 1,000 users. So she randomly selected 1,000 users, right? 1,000 users, and that gave her 1,000 users, which is over here. 1,000 randomly selected users. So now, because we know it's randomly selected, we can actually apply or generalize these conclusions to all users. We can generalize results to all users in, or who uses her websites, or to all users in general, right? Who's gonna use her websites. Okay. Okay. Can we conclude that the new design caused users to spend more time on the site? Why? Okay. And then, yes, because the sample size was large. Well, there's also such thing as a too large of a sample size. Okay, yes, because the users were randomly assigned to treatment and control groups. Isn't that always the answer? They were randomly assigned. Yes, because the users were randomly selected. They were randomly selected. So what in the world? Not necessarily because the sample size was too small. No, not necessarily because this was an experiment. It is definitely an experiment. I'm gonna think. Yeah. Oh, interesting. So randomly selecting users helps us get a representative sample of all users, but it doesn't mean we can make a casual conclusion. So because a user is randomly assigned, oh no, not this one. What was the one that I found interesting? Because the sample size, no. Oh no, yeah. Randomly selecting users helps us get a representative sample of all users, but it doesn't mean we can make a casual conclusion. Oh, so yeah, so to further emphasize on the point, because we randomly selected, it's more of a representative sample of all users, which is why you can generalize your results to all users. Well, if you don't randomly select and you just take a bunch of volunteer of users, like 1,000 volunteer users, or users who volunteer for your experiment, then that's not representative of your sample. Like, that could just be people who really want to volunteer, and maybe those people have qualities of being like very attentive or very, I don't know, kind of like helpful and smart, and like if they're smarter, then maybe they'll have easier time navigating your website, and that could like be a confounding variable, and like blah blah blah. So representative sample means it's randomly selected, and therefore you can generalize your generalized results to all your users. If it's not randomly selected, and if it's just volunteers, then you cannot generalize your results to all users, and you can only generalize to the 1,000 users that you conducted the experiment with. And I'm repeating this because this is how I remember stuff. So, reiterating. Okay, so where were we? Okay, so I think we did emphasize that point above, that random selection doesn't mean it's an experiment. It just means that it helps for a representative sample. Okay. The superintendent of a large school district is curious about the relationship between students' grades and their participation in extracurricular activities. Really? Relationship between students' grades and clubs. They take a random sample of 500. So we have 500 students. And find out students with more participation. There was no random assignment. What? What? What does this mean? Okay, 500 students, and find that students with more participation in extracurricular activities are far more likely to have high grades than students with little or no participation. So it's definitely an observational study because there's no random assignment. There's a random selection, but again, random selection does not equal an experiment. It just means that what it does equal is it's a representative sample of the population, in this case, of students. Okay. So it's definitely not an experiment. So it's an observational study. So we can't prove causation. So we can't say that this causes that. But they're really asking for a relationship. Okay, so let's look at the answer choices. So what conclusion can they draw from this study? So for any two students in this study, the one who participated more in extracurricular, okay, definitely not. Like, where do you even get that from? Any student in the study who participated in extracurricular has to know. There was an association between extracurricular participation and grades, but it's not necessarily a casual relationship. Oh, a causal, like not casual, like causal, like a caused relation, like a, what am I saying? Like a, why can't I talk? Oh my god. Casual, like a casual, it's not casual, it's causal. It cannot be pronounced casual because it's not casual. I know it's referring to like causing, so it can't be casual. Extracurricular participation caused the students to have higher grades. Definitely not. Higher grades cause the students, okay, no, so it's definitely C. Yeah. So this was an observational study since students were not randomly assigned to treatment groups. So we can say that there is an association or relationship, extracurricular participation and grades. Since this wasn't an experiment, we don't necessarily know that extracurricular participation caused higher grades. Interesting, I love it. So yeah, so this is an observational experiment. An observational study. So note, so observational study, we can observe a relationship, but we can't say that one like treatment or variable causes, etc., like causes whatever. Like we can't mention the word cause, just don't mention the word cause if it's an observational study. So I'm thinking, why am I thinking of like linear regression? So like if you have two variables, side note, you can ignore me. So if you have two variables, right, and it's an observational, not an observational study. It's like you have two variables, you find the LSRL, linear least square regression line, right? The line of best fit. And you can see that there's a relationship, but you can't say that for sure. You need to find. Well, no, it depends if it's an observational study or. Okay, anyway, back to the problem. We'll get there. I want to be done. So, a grocery store wonders if their sales will be better if they place ambient music or no music at all. Each day for 2 months, the manager flips a coin to determine whether or not the store will play music that day. At the end of the 2 months, the manager finds that on average, sales were generally better on days where music was playing. Oh my god. Okay. So again, experiment. So each day for 2 months, the manager flips a coin. So there is random assignment. There's it's flipping the coin. It's completely randomized. So yeah, that's what random assignment means. Kind of. Can it be replicated? Well, I would say that, it's 2 months and then another 2 months, so I would say it's a big sample size. Control. I don't think there's any other finds that our sales were significantly better on days. There can definitely be better control. But we could just, this is a very lenient condition. Because, all designs are fine. And then 5, what was the other one? So, random assignment, control group. So, control group finds out our sales. Control group, it would be like the no music playing, so that's fine. But is an experiment, there is random assignment, yes. But were there treatments assigned to certain days? Yes. So, yes, any store, okay. There was an association between music and sales, but not a relationship, but it was an experiment though. Any store could increase sales by playing the same music. Any day where music was played had higher sales than a day where no music was played. Better sales cause no, it's wrong. Playing music caused better sales, where any day where music was played had higher sales than a day where no music was played. Interesting, but it says that sales were significantly better. So when I hear that word significantly, that's a whole unit, man. That's like hypothesis, like, oh my god. So if, that's a lot. So I think, yeah, we can say cause because it's significantly better. So it's not due to random chance. I don't know. Should we say A? Oh, okay. See, we're good. Yeah, so random assignment each day, music or not, makes the study an experiment so we can make causal, okay, we need to, causal conclusions. How do you pronounce that? Causal conclusion. Pronounce. It's not casual, it's causal. Casual is something different.
Causal.
Oh, causal. Okay. Causal. Why does it say, why do I sound so weird? Causal conclusion. A causal conclusion. Okay. Researchers were interested in the relationship between farmers' approach to their cows and the cow's milk yield. After surveying a random sample of 120 farmers, the researchers found that I was reading it, yet I have no idea what I read. Like, what's wrong with me? Okay, let's start again. Researchers were interested in the relationship between farmers' approach to their cows and the cow's milk yield. So basically, how the cows are treated, and how much milk they give. After surveying a random sample of 120 farmers. The researcher found that on farms where cows were called, oh, this is definitely an observational study because there's no random assignment. So again, I just want to reiterate. Here's my circle of farmers. And we're taking a whole bunch of farmers. We're doing an simple random sample, right? Taking a whole bunch of farmers. And we end up with 120 farmers, and that's our random sample. So these farmers were randomly selected. They were randomly selected, but that does not mean it's an experiment. What means it's an experiment is if they were randomly assigned to a treatment, but they weren't randomly assigned to a treatment. They were just asked their opinion. Not their opinion. They were just asked for what they had observed, like what data had they observed, like how much yield there was. So the researchers found that on farms where the cows were called by name, milk yield was 250 liters higher on average than on farms where this was not the case. Can we conclude that calling the cows by name caused the cows to produce more milk? Why? No, we cannot, because this was an experiment. This was an observational study. Okay. Can we be done with this? Okay, this is the last one. A majority of people who receive surveys in the mail don't respond. Oh my god. What? Man, I just want to sleep, you know? Like, I really want to sleep right now. Like, I want to sleep so bad. But it's okay. Like, it's okay. Summer's coming. Spring break is coming. And after spring break... Oh, wait. I have a test. Never mind. I have the AP stat test. I'm gonna cry. Oh my god, I forgot about that. As I'm literally studying for stat, I forget that I have a whole test, like a real test. Okay. A majority of people who receive surveys in the mail... I'm not gonna cry. I have God. We're fine. Thank you, Jesus. So, a majority of people who receive surveys in the mail don't respond. Researchers were curious which type of reward would be most effective. Send someone $10 after they mail a completed survey back, or send someone $5 with a survey as an advance thank you that they can keep whether or not they participate. The researchers chose a random sample of 1,200 adults, and randomly assigned each of them to one of three groups. So we have $10, $5, so after survey, before survey, and then I'm assuming this is no reward, which is can you guess the control group? Okay. So, they found that people in the $5 group were significantly more likely to send the survey back than people in either of the other groups. So if we compare results, compare effectiveness, compare effectiveness of reward. By seeing which reward caused people to send or to complete the survey, to send the survey in. And what is the question? What conclusion can they draw from this study? Okay, so before going into anything, I am going to reiterate for the 5,000th time. I'm doing this for me. Wait, I'm doing this more for myself because this is how I learn. By applying the same concept to 5,000 different problems. So what's the thing? We have adults. Yeah, just adults. So that's the population, and we're taking the population and we're conducting a SRS, so a simple random sample, a whole bunch of samples, and pretend that there's 1,200 dots, and that makes that 1,200 adults randomly selected, which means it's more of a representative sample of all adults, right? Of all adults, or of all adults in the population, or of the entire population of adults, or of the population, period. Okay, so because it's a more representative sample of all adults, we can generalize the results to all adults and not just the 1,200 adults used in the sample. Okay? So we can say, what was the conclusion? That the $5, so the conclusion was that the $5 caused the adults, so let's change this to adults, cause adults to send survey back more than the other groups. I would have said rewards, but the no reward is literally not a reward, it's a control group. So $5 caused adults to send survey back more than the other groups. So here's the thing, cause adults, so this is what it changes. So if it's randomly selected, we could say adults. If it's not randomly selected, we would have said $5 caused the 1,200 adults out of, okay, $5, the $5 reward causes the adults in the sample, so, or the 1,200 adults, to send survey back more than the other groups. Okay, but because we randomly selected a sample of all adults, then that's a representative sample of all adults, and therefore we can generalize our results to all adults. And so we can say the $5 reward caused all adults, or we can say that in all adults, we can say all adults will, well, all I have to say is all adults will, there is, okay, a $5 reward will cause all adults to send survey back more than the other groups. Okay, there we go. So which conclusion can they draw from the study? Survey completion caused the difference in reward type? No, it's the opposite. Reward type caused difference in survey completion. The $5 in advance caused a difference in survey completion. Yes. In the population of all adults. Any person given $5 will complete the survey. You don't know that. No, we don't know if they will. That's why I was like struggling a little here to make the conclusion. We don't know if any person will, it's just started. Okay, anyway, any amount of money given in advance will lead to a higher, no. Okay, finally we're done. Oh, maybe I should take a chocolate break, because I have a chocolate bunny right now and I'm eating it. Yeah, I bought it at BJ's and I've been eating it very slowly because I don't like eating too many sweets, but for some reason I can't stop snacking. So yeah, we're doing that today. Maybe I should take a chocolate bunny break and watch some Hannah Montana on Disney Plus. That's what I've been doing. I'm on season 2. I don't know what's with me. I've been watching very kids shows recently because I don't know. I just find it it's very low key and there's no commitment to watching Hannah Montana. But if I'm watching a serious show, I feel like I have to finish it in a day. Like my books, I have to finish my books in a day. I have issues. Okay. I don't know. They're just too good. And it's not that Hannah Montana isn't good. Okay, you know what? I'm rambling. I'm just gonna eat my chocolate and I'll be right back. Okay, so let me pause this. Oh, my mouse isn't working and I love that. Okay, I'm back. So, finding errors in study conclusions. So, a gym that specializes in weight loss offers its members an optional dietary program for an extra fee. To study the effectiveness, the effectiveness of the manager, the gym takes a random sample of 50 members. Oh my god. Okay, this is literally, I cannot do this anymore. This has to be the last one. Okay, okay, a random sample of 50 members who participate in the dietary program and 50 members who don't. So we have a gym, right? Gym members, right? And I'm assuming that out of the gym members, we're taking those gym members who are in the dietary program and those who are not in the dietary program, and they take a sample of 50 from each. And then the manager found that those who participated in the dietary program. What? The manager concludes that the dietary program caused the increased weight loss. I'm literally so done. Okay, the manager finds that those who participated in the dietary program on average lost significantly more weight than those who didn't. Wait. So what? What? So is it just 100 members? I don't think it's 100 members. It's not randomly assigned, so like 50. To like a treatment. Okay, so why can't I think right now? So a gym specializes in weight loss, offers its members an optional dietary program for an extra fee. To study the effectiveness of the dietary program, a manager at the gym takes a random sample of 50 members who participate in the... okay, wait, so members, right? And so 50, but they weren't randomly assigned though. Wait, they weren't randomly assigned. They were randomly selected. So the manager finds that those who participate in their program on average. So the dietary, so participate in program, don't participate. And they compare the results, and they said, okay, those who participate in program I cannot even spell. So participate lost more weight. At this point, I don't even think I'm gonna post this. This is literally 2 hours long. Okay, the manager concludes that the dietary program caused increased weight loss for gym members during that time period. What is a confounding variable that makes their conclusion inappropriate? Oh, what the heck? I don't know, man. The members' choice of whether or not they participate. Yeah, exactly. Like, it was literally... Well, no, it was randomly selected. But that doesn't make sense, though, because... I'm so confused. Wait. The lack of replication to other time periods, no, that doesn't really matter, because there were other experiments where, or observational studies too, that were just like 2 months or etc. The random sample of 50 members, no, that makes it even more of a representative sample, which reduces, well, no, random assignment reduces confounding variables. Random selection reduces sampling variability. The exclusion of non-members in the study. The members included the dietary program. We don't care about non-members. a lack of attention to the placebo effect. Oh, interesting. More weight than those. Yeah, probably the placebo effect one. And the members' choice of whether or not they participated in the dietary program. What choice? It doesn't matter. Like, they're randomly selected. So... pretty sure it's not what it is. No? Okay, great. See, I knew this was a hard one. Maybe this one. Yeah. Oh my god. So the manager's study lacked random assignment. The member's choice of whether or not they see, that's what I said. Technically, I was confused, right? Because where was the random assignment? Like, there was no random assignment to like the treatments, right? It was just saying, okay, 50. It was just wait. Oh, it wasn't an experiment. Duh. So they literally just took 50. Oh my god, I'm so smart, bro. So smart. By the way, if you don't know me, when I say I'm so smart, I mean the complete opposite. So I just don't like saying negative things. Okay. Or professing negative things, I guess. Okay, anyway, so wait, what was I saying? What was it? Okay, yeah. So they literally just said, okay, people who take the diet program, like they took randomly selected 50 people, and then like they just said, okay, those who took the diet program weigh less, right? And then the 50 who didn't take the diet program just didn't weigh less. So this one's a win. But that was just an observation. Like, there was no assignment of treatments. Okay. Ricardo suspects that his cat will prefer a new cat food to their current cat food. For his cat's next feeding, he decides to feed his cat in a different room than usual. He puts a bowl of the new food on one side of the room and a bowl of the current food on the other side of the room, determined by a coin flip. So the treatments are randomly assigned. Okay. His cat chooses the new food. Prefers the new food to their current food. Okay, definitely not the first one. Definitely not this one. The lack of attention that what? No, it's a cat. The lack of replication to other feedings. The exclusion of other cat foods. Actually, what? These don't even make sense, man. So this is like, let's just delete that. Okay. So Ricardo says that his cat will prefer a new cat food to their current. So here's the room. Right, here's bowl number 1. Here's bowl number 2. Right, so this is new. Let's say this is new. This is old instead of 1 and 2. Bowl of the new food on one side, and he randomly assigns. So he randomly assigns the side of the room to, doesn't make sense. He assigns, so for each side, no. He assigns side 1, side 2, side 1. He assigns the bowls. That doesn't make sense. Bowls to one side. What? What? He puts a bowl of the new food on one side of the room and a bowl of the current food on the other side of the room. Determined by a coin flip, his cat chooses the new food. Ricardo concludes that his cat prefers the new food to their current food. The sample size is so small that like it's just one time. So what? So the exclusion of other cat foods, the lack of replication to other feedings, the random assignment. I think it's this one, the lack of replication to other feedings. Yeah, because it's like it literally only happens once, and that could just be by chance. Okay. Right. Okay. Researchers recruited participants for a wine tasting study that included a variety of wines in terms of style and price. The participants tasted a series of wines in a random order. Participants could look at the bottle for each wine so that they could take its price and label from blah 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 blah. Here's that conclude more expensive wine tastes better. What is a confounding variable that make their conclusion inappropriate? What? Okay. Researchers recruited participants for a wine tasting study. The use of volunteers. Like what? Tested a series of wines random order, participants could look at the bottle for each wine so they could take its price and label into account. That doesn't make sense. What? The lack of control, that group that doesn't know, the random order, no. The lack of blinding, the exclusion of beverages other than wine, no. The lack of blinding. First of all, that doesn't even make sense. The lack of blinding. So the participants could look at the bottle for each wine so they could take its price and label information into account as they tasted and rated each wine. That's like, yeah, that's like, what? Maybe it's that one, or maybe it's a use of volunteers. Because research recruited participants who volunteered. So it's definitely not, it's literally not even an experiment. It's not, but yeah. So the use of volunteers is not even a confounding variable. Right. Okay, it's a good thing, kind of. Just can't generalize. Okay. Seeing the price of each wine is a confounding variable that participants might already think that expensive wines will taste better than cheaper wines. Okay, a class was curious if their teacher could grade and return double-spaced papers faster than single-spaced papers. Like, am I right? Like, MLA format for what? Okay, for a certain assignment, each student flipped a coin to determine if they would single-space or double-space their paper. The student agreed to all use the same font. Good. The student who double-spaced received their grade papers accidentally faster than people. Okay, blah, blah. The class concluded that any teacher, no, can grade, no, and return papers faster if they are double-spaced rather than single-spaced. Interesting. So is it an experiment? So why is the conclusion not appropriate? Well, they're saying that any teacher, first of all, any teacher, and we can only apply our results to any teacher or to the whole population of teachers, which is the same thing, if the group or the experimental unit was randomly selected. And the experimental unit was not randomly selected. It was just one teacher. So we can't say any teacher. And also, is it an experiment or is it not an experiment? So if it's an experiment, it has random assignment, but it has random assignments to different treatments. There are two different treatments, so double-spaced and single-spaced. So double-spaced being, the treatment, and then single-spaced being the control group, but where they randomly assigned, each student flips a coin to determine if they would, yes, they were randomly assigned. And then there's comparison, there's control group, there's control. So the only thing is that you can't generalize the results to the whole population. So the study, no. The study was an experiment, but it didn't group the students into blocks, no. The study wasn't a census. The study was an experiment, but it didn't include anyone other than their teacher. Yeah, that's the one. So this was an experiment since each student was randomly assigned a treatment, double-spaced or single-spaced. It's appropriate to make a causal conclusion, but their study only included their teacher, so they shouldn't make a conclusion about any other teacher. And just so that we can see the whole thing, we have the teacher, right? And we have, what is it? So we have double space, single space. Interesting, wait. We don't have the teacher, we have the papers. And they were double space and single space, and then compare teachers grading what? Grading fastness, grading time. So papers, they were randomly assigned double space or single space. Compare teachers' grading time. And it was just, but usually the population is here. This is the experimental. Interesting. Or maybe it's not the papers, but it's the papers that she's grading. So it's the teacher, right? And so the teacher is being randomly assigned double-spaced papers and single-spaced papers, and then you're comparing teachers' grading time. So this would be like, you would have a population of teachers, but since you only took one teacher and it wasn't randomly selected, you can't even read what I said. What? And if it wasn't randomly selected, we can't generalize results. We can't generalize results to any teacher, right? Specifically to any teacher. But we can generalize results to that one teacher. Right? Okay. I really like this example. This is another good one. So this is about generalizing results. Okay. Moving on. Oh, we're done? Like what? What do you want me to do now? What's the next one? How do we go on? It's not letting me go on. This is just disrespectful. Oh, we finished? No, we didn't, did we? Oh my god, we finished the whole thing? No. Oh, this is a whole unit. Okay, hold on. Oh, this is horrifying. Oh, this is so annoying. I'm gonna cry. No, or no. I want sampling. I did experimental design. Now I want sampling. I need practice on sampling. Principles of experimental design. Collecting data. Let's go out of here. What? Let's go here. AP college statistics. Okay, we did explore categorical data. Where is collecting data? I'm so confused. Language. Boring. Two-way frequency. I'm telling you, if they give me a mosaic plot, it's over. It's over. Like, I'm not doing that. I'm not even gonna bother. Okay, so no. Exploring one variable quantitative. Where is... Wait, oh, I'm in the wrong thing. I'm supposed to be looking at the experiment. Exploring two, collecting data here, right? Probability, collecting data, introduction, sampling. We're sample. Potential problems with sampling, introduction to planning a study, random sampling, and data collection. So this is the one, yeah, perfect. Collecting data, and I'm trying to find, I was here though. Oh, example of bias, identifying bias and sampling surveys. But like, isn't there like a practice for like bias ones, like types of, did we do this? Oh, no, I do not want to watch a video, please. Okay, okay, I guess this one we can do. What? What is this? Ugh. Okay, I guess we could do this. It's important to identify, oh my god, potential sources of bias when planning a sample survey. When we say there's potential bias, we should also be able to argue if the results will probably be an overestimate or an underestimate. Oh my god, I can use this in my research project. I literally have a presentation in April 12th, and I could definitely do this because I did do an experiment. Didn't I? I took a random sample of stratified random sample of teachers, and I randomly, wait, did I randomly assign them? No, that's not an experiment, that's an observational study, because I didn't randomly assign them to any treatment. Exactly, sorry, what are you saying? Okay, anyway, so, but we could still say like overestimate or underestimate. So try to identify the source of the bias in each scenario and speculate on the direction of the bias. Okay. Scenario 1. David hosts a podcast and he is curious how much his listeners like his show. He decides to start with the online poll. He asks his listeners to visit his website and participate in the poll. The poll shows that 89% of the 200 respondents love his show. Okay, so if we think about it, right, the people who really, really, really love his show are going to probably be the most likely to go and say that they love his show. If people don't really care about it, it doesn't take into account people who don't even care about the show. It doesn't take into account people who hate the show because maybe they hate it so much that they don't even bother. Just like the people who don't care about the show, they don't bother to answer the survey. So those who really, really love the show, are always going to be like very supportive and go answer the question, which is why that this might be an overestimate of the people who really like his show. So that is see, is that response bias or under coverage? So it's not covering, I think it's under coverage because it's not covering everybody. Or maybe it's response bias because response bias. So like when people say, well, not really, I think it's under coverage. Are you joking? Voluntary response. Okay, but it could be under coverage too, right? Like you're not covering. Oh, well, yeah, you are. You're covering like everybody, and it's just, oh, yeah, you're covering everybody, but not everybody has to do it. So that's voluntary response sampling. But it could also be. Okay, well, I know this one. It's overestimate because you're in the middle of the show. Yeah. Okay. Scenario 2. David hosts a podcast and he is curious how much his listeners. Isn't it the same thing? 100. The next 100 listeners who send him what? They don't all respond, but 94 out of the 97 listeners who respond say they love the show. It's not convenience. It's non-response. You're joking. At this point, I give up. Convenience sampling. Great. This is amazing. Sorry. Okay, convenience sampling. Why? Wait. Concerning source of bias in this scenario. David hosts a podcast and he is curious how much his listeners like his show. He decides to pull the next 100 listeners who sent him fan emails. Oh, convenience sampling, like systematic. Okay, not systematic, but. Oh yeah, convenience sampling means like the first blah blah blah, right? So that's not random sampled, so that's bias. Okay, which direction of bias is more likely in the scenario? We're probably an underestimate of the percentage. What's the percentage? I didn't even say it. 94 of the 97 who said they loved his show. Probably an overestimate. Or is it probably an unbiased estimate? Okay. A senator wanted to know about how people in her state felt about internet privacy issues. She conducted a poll by calling 100 people whose names were randomly sampled from the phone book. Note that mobile phones and unlisted numbers aren't in phone books. So this is under coverage. Yeah, because it's not getting everybody. It's not getting people who have mobile phones and not getting people who don't have phone numbers. What was the result? Poll showed that 42% of the respondents were it's probably an underestimate. Well, very concerned. Or maybe an overestimate. Yeah, understood. A senator wanted to know about how people in her state felt about internet privacy issues. She conducted a poll by calling people using random digit dialing, where computers randomly generate phone numbers so unlisted and mobile numbers can still be reached, which is better, so that takes care of under coverage. They called over 1,000 random phone numbers. Most people didn't answer until they had reached 100 respondents. The poll showed that 46% of respondents were very concerned about internet privacy. Response. Which direction of bias is more likely in the scenario? What was it? So that 46% probably an underestimate because of non-response, because only like 100 out of 1,000. Okay. The high school wanted to know what percent of its students smoked cigarettes during the week when students visited the counselors to schedule classes. They asked every student in person if they smoked cigarettes or not. That's definitely response bias, because how are you gonna, like, people are just like not gonna answer you, especially if you're like an administrator and you're a student. Like, you're gonna have like should I answer the question, should I not? People can lie. Which direction of bias is more likely? Probably an underestimate, because you're underestimating. Yeah. Okay, a high school scenario. High school wanted to know what percent of its students smoke cigarettes. Counselors select a random sample of students to take a survey on drug use. One of the questions: if you're under the age of 18 years, do you illegally smoke? This is bias wording. What were the results? Underestimate. Okay. Oh, what's that? Oh, take the quiz. What? I thought that was. That's so annoying. Okay, so according to a study published in the journal Psychological Medicine, can help people with depression. The study involved 29 participants who all had depression. Doctors gave each of the participants either a blah 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 or a placebo beverage that looked tasted similar. Yeah, but they were randomly assigned. Those who drank blah blah blah. This is an observation of the type of drink, the response variable. Oh, not this again. So, okay, response. So we have explanatory versus response variable. So explanatory, your X, response is your Y, X causes Y. Okay, that's great. So, an observational study where the type of drink. So response in this case would be would be depression. And then this would be the type of drink. So X usually explains. That's so ugly. Explains Y. So type of drink explains depression. So, yeah. So it's an observational study where the response variable is the depression level. Okay. Is it an experiment? How is this an experiment? Experiment. The participants were assigned to a treatment. What do you mean assigned to a treatment? They weren't assigned to a treatment. They weren't randomly assigned to a treatment. The study involved 29 participants who all had depression. Doctors gave each of the participants either blah 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 or a placebo beverage that looked and tasted similar. But they didn't say, though. They were assigned to a treatment, but they weren't randomly assigned to a treatment. Oh my god, this is so annoying. So they have to be randomly assigned. See, Khan Academy was wrong. I'm right, totally. Right? Sure. No, because I know randomly assignment, please. They have to be randomly assigned. But I didn't know they can just be assigned. No, they have to be randomly assigned. They just can't be assigned. Does that make sense? What? Okay, this low-key, I don't like this question. Because it has to be randomly assigned. It literally says it. Look, it says it has to be, where is it? The first one, random assignment, right? Random assignment. It's not just assignment, it's random assignment. An experiment where depression level was a response variable. So the participants were assigned to a treatment. So this study is an experiment. No, sorry, but they have to be randomly assigned. I do not agree. A group of librarians is interested in the number of books, or maybe I should just ask my stat teacher. Okay, a group of librarians is interested in the number of books and other media plans. The examiner check out reports randomly selected developers and publishers. Ugh. Okay. So. The population. That is a horrifying circle. Is the adult patrons, and the sample is 150 adult patrons. So population is all adult patrons of the library. The sample is 150 patrons selected. A dentist wants to conduct a survey via telephone to determine what % of all adults in their city floss daily. Which of these is the best example of response bias? Well, the fact that people will know that he's a dentist, so people will be like, sure, because they're afraid to be judged. Some people might not answer their phone after repeated calls. People with unlisted phone numbers know. Some people might refuse to tell a stranger on the phone about their flossing habits. Some people might feel pressured to say they floss even though they don't. Yes, this is the response bias one. Okay. A company that recently changed its slogan is hosting an optional company picnic. Some members of the marketing team are eating together at the picnic and sharing their thoughts on the new slogan. I find that 80%, for which population is 80% legitimate at 70% of employees who like the new slogan? The company that recently changed its slogan is hosting an optional company picnic. Some members, only those members of the marketing team eating together at the picnic, because they weren't even randomly selected. They're just some members, so you can't generalize it to the whole population and only to those members eating at the picnic. Okay. Grace was curious if married people were more likely to be safe drivers than unmarried people. Grace took a random sample of car accident records from the past 5 years in her country, and she calculated what % of accidents in the sample were caused by married people. She compared the result with the percentage of all drivers in the country that were married during that time period. What type of observational study is this? Oh, not this again. I literally did not even remember this. Types of observational study. This is just torture now. Types of observational studies. So, I don't know, man. I don't know. It's definitely not an experiment. What? Oh, maybe it is an experiment, because she said she calculated what % of accidents in the sample. No, it's not an experiment. Retrospective. Retro means back in the day, so yeah. I love how I know that. I love that's so funny. Retrospective study, because it's a study of the past. Man, I don't even know. I just saw retro and I was like, back in the day. So what's retrospective? I'm not really gonna focus on this because she didn't even mention this. Okay, oh my god, I remember this. Willie runs a small company with 10 employees. He decides to pick a simple random sample of 3 employees to go on a business trip. He numbers them 0 to 9 and uses the random digits, blah, 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 blah. Okay. What? Which employees are in the sample? I don't know, man. How am I supposed to know? I completely forgot how to do this. Okay, isn't it just 105? It's 105. Oh, yeah, because 3, so it goes in order 105, and you don't take repeating samples. Because they're employees. Yeah, okay. See, I totally knew that. Yep, sure. Willie runs a small company with 10 employees. He decides to pick a sample of 3 employees to go on a business trip. 0 to 9. So this is 692. It's 3, right? Okay. 3 employees. So it's 857. Okay, this stuff is on printing and book writing with the machine isn't putting enough glue into the book. Oh, I remember this problem. I love how everything, oh my god, I remember it. It's crazy. I feel like this is the one I researched. 70 textbooks to study his theory. He numbered them 0 to 170. There's 5 books. Okay, 5. So it's 0, 5, 0, 5, 0, 5. Oh, 2 digits. Okay, 2 digits. So 0, 5, 71, 0, 5. Oh no, 0, 5, 0, 0, 71, 66, 0, 5, since it's doubled. No! Oh, it can't contain 0, 0. Okay, so it's 0, 5, 70, no, 0, 7, 16. Oh, is this a joke? Must be taken. It is in pairs though. What do you mean? Oh, wait, no, that doesn't make sense. It doesn't make sense. 0 to 1 to 70. What? What number falls outside of the range of 0 to 1 to 70? You have 0, 5. It's greater than 0, 1. 0, 7. Greater than 0, 1. 16. Greater than 63. Inside. What does this even mean? 0, 5. You can't take into account 0, 0. So you can't take into account 70. Oh! Okay, so you skip 0, 0. You skip 71 because it's greater than 70. And so you have 66. So it's 0, 5, 66. And then after 0, 6, 66, we have 0, 0, 5. So it's C. You're free. I'm done. Oh, oh my god, this is embarrassing. So it's D. Okay, because, okay. So this is a lesson. It's a good lesson. So you can't repeat. So you can't repeat samples, right? Well, what do you call them? You can't repeat samples. What else? You can't repeat samples. You can't get samples or use samples outside of the range. And if it's double digits, if range is double digits, so like 0, 1 is 70, then the sample number should also be with double digits. I'm just gonna say 2 times D, double digits. Okay, well that was embarrassing, literally, like getting one wrong after the other. Sorry, come on. See, I knew I remember. Oh my god, this is so funny. I knew I remember this problem for a reason. I was like, I remember this problem. I wonder why, because I got it wrong, and I still got it wrong today. Literally, why? Oh my god. Okay, so yes, let's move on. Let's try one of these again. Try again. Okay, there are 90 students in a lunch period, and 5 of them will be selected at random for cleaning duty every week. Each student receives a number from 0, 1 to 90, and the school user random, blah, blah, blah. So, okay, we have 24, we have 70, we have 97, and we can't use that number because it's outside of the range. Okay, then after 97, we have 36. And after 36, we have 98, and we can't use that number because it's outside of the range. After 98, we have 14. And after 14, we have 52. So a random sample is 24, 70, 36, 14, and 52. Okay, see, we're getting better. Okay, Mr. Thompson runs his own printing and bookbinding business. Oh, not this one again. He suspects, okay, so basically I just want a random sample of 5 books from 0, 1 to 70. So, okay, so what? So 27, 77 oh no, 78, excuse me. 78 we can't use. So 27, 78, 88 we can't use. Then we have 80, oh no, I'm getting lost. So 27, 78, 88, 57 we can use. After 57 we have 89, which we can't use. After 89 we have 41, which we can use, and then 59. And after 59 we have 27. And we can't use that because it's repeating. So again, no repeating, because we have it here, 27. And then after 27, I lost my place. What is this? 44. Okay, 44. Why can't I see my pen? Okay, 44. So what is it? 27, 57, 41, 59, 44. 41, 59, 44. Okay. Moving on. Mr. Okay, so again, out of 70, they want a sample of 5, 0, 1 to 70. So we have 37, 56, 98. We can't use 98. So we have 51. And then we have 87. We can't use 87. And then we have 44. Then 69. 1, 2, 3, 4, 5. So it's 37, 56, 51, 44, 69. Okay, this one we have 90 students. We need a random sample of 5, 0, 1 to 90. So it's gonna be 0, 6. 91 we can't use. Then we have 57. Then we have 29. Then we have 54. And then we have 10. So what is it? 0, 6, 57, 29, 54, and 10. Why are they always A? Moving on, so that's selecting a random sample. So no repeating numbers like we saw over here. We can't use repeating numbers. We can't use numbers outside of the range. So can't repeat samples. We can't use outside of the range, and I think that's it. Okay. Can we please? Okay, sampling methods. This is the one that I wanted. Sampling methods. I want to go over sampling methods. Oh, and let me do, so this is when performing an SRS. Okay. Inspectors for a hospital chain with multiple locations randomly select some of their locations. Oh no, yeah, this is where I need to practice because I hate this. So this is basically during an experiment, we have our group and we randomly assign to different treatments, like treatment 1, treatment 2, and we randomly assign. Yeah, this is the part we're looking for. This is the part that we're doing right now, that random assignment. So we can do random assignment of stratified random sample and SRS. We can use cluster sample, systematic sample, like whatever, you know? Okay, so inspectors for a hospital chain with multiple locations randomly select some of their locations for cleanliness check of their operating room. They check every operating room in the hospitals that were chosen. So what? So it's not cluster, because cluster would be selecting all of the locations and then only selecting one and like looking at that operating room. So it's not cluster. Is it even a random sample? A stratified random sample. I think it's a stratified random sample because out of all of the locations, they picked like a few, and out of the few, well no, a stratified random sample would be they picked a few, and then out of the few they picked a few more. I have no idea. I have like literally no idea. Like I have absolutely no idea. Like is it cluster? How is it literally tell me it's over? I thought cluster was only one. Okay, and they don't even provide you with an explanation. Like how am I supposed to know this? Okay, so cluster is selecting out of all. Okay, no. Let's use a hint, please. Are you joking? Okay, not every subset of operating rooms had the same chance of being selected, so this is not a simple random sample. Oh my god, this is heaven. Literally, God, what a blessing. Yeah, let me just take a screenshot. See, if we only knew this. Okay, let's go to copy. I'm gonna copy and then we're gonna go to Notion. Literally falling. Okay. Okay. Where are we? Life. Oops. Let's not go to life. Let's not go to. Okay. There we go. Actually, we don't really care. Wait, what happened? So annoying. What? No. So slow. Okay, math logs. Okay. What even is this about? Oh, it's sampling. Sampling, what methods? Sampling methods? I literally don't even care. What date? Oh my god. Is it Tuesday still? How is this even possible? Okay, paste the image. There we go. Okay, we're gonna do what? Subject stats. Why do I have freak out? Did I even freak out? Oh, it's because it was 2. I forgot. Okay, what is it I doing? Sampling. Is that really right? You couldn't do. Oh my god. Sampling. Why do I feel like just watching like She-Ra? Like, what's wrong with me? Like, so when I watch She-Ra. Okay, so let's look through this. So a cluster random sample. We divide the population into groups called clusters, and then we randomly choose some of the groups and we include every member in those groups. What? When each of the group is similar to the population. What? See, like, it's giving simple random sample, simple which has been chosen. What happened? No, wrong one. Okay, let's see if we can get this right. A student council surveys 100 students by taking random samples of 25 freshmen. Oh, this is definitely stratified. I know that from heart. I use that in my research project. Literally #A. Literally #best sampling method ever. But yeah, the reason is because 100 students, you take population of like students, 100 students, and from each 100 students, you kind of separate them. Oh, this is why people get confused between block and stratified. Block is the design. Sampling is how you select. So it's like you take, out of the 100 students, you take some freshmen, some seniors, some sophomores, some, what are they? Juniors. And then you take a simple random sample out of those, and that gives you, your group. Okay. Next. Each student at a school has, I want Chinese food. Each student, well, I had it last night. Anyway. Each student at a school has a student identification number. Each school at a school, sorry? Each student at a school has a student identification number. They also have a computer generate 50 random identification numbers. What type of sample is this? What? Man, I don't know. Convenience, voluntary, simple, random sample. I guess, because each student has an equal chance of being chosen. Like, girl, what? So, okay. So a simple random sample of an SRS. And you have a pool of like all students. And they can all equal chance of being chosen. Stratified would be if you have students, right? And out of those students, you have some freshmen, some the juniors, seniors, and sophomores, and then inside you would take like a simple random sample of a few freshmen, a few juniors, a few seniors. Right? That's one SRS. One SRS. This is like all an SRS. This is so messy, but it's fine. This is another SRS, and so there you would have like random sample. And then cluster, don't even get me started with cluster. I literally have no idea. Systematic though, I can tell you. Oh, what the? Okay, first of all, why did I be disrespectful? Okay, and then systematic is if you were just take the students and just take like the first 100 students you see, like the first 100 students you see. Okay, and then cluster, man, I don't even know, like for real. So stratus, that's horrifying. I'm literally, this is the messiest thing I've ever done in life. So SRS, stratified, systematic, cluster. I just don't understand cluster, like for real. Like what is cluster? So cluster would be what? Like you would have your students. I feel like this would make sense for schools, like I just don't understand, like the other one like had an operating room thing, so like had different locations. So they had like different locations. They had all of their locations, and they just took different, or I guess they took like towns, like they had different towns, and so I guess this is what happens, like you have a hospital that has like different locations as in towns, so like each circle is a town, and they only picked one circle, and out of those one circles they picked all of the locations in that circle, and I guess they performed an SRS for each of them or something. I don't even know. So this is like to be revised, man, because I have no idea what clusters are. I forgot. Okay, security workers at an airport randomly chosen one of the first 50. Oh, this is systematic again because it's one of the first 100, first 50, first whatever. Okay. A professor asked the first 5 students. Okay, systematic again. When you okay, fine. Let's slow down. The first 5 students who arrived to class to participate in a research study about the young adult sleeping patterns. What sample is this? How is it not systematic? Sample random sample, stratified random sample, none of the above. It's literally, tell me how. Oh! Okay, but it literally is a systematic random sample though, because it's literally the first 5 students. Convenient sample, did we have that? They mentioned convenient sample is we select individuals who are readily available or easy to reach. Then what's the difference between systematic and... Okay, systematic is we put the population, or it comes to us in some ordered arrangement. We randomly select one of the first K individuals and choose every Kth individual. Oh, okay. So it's when we do it on purpose. Like we do it on purpose. See, sure, I totally understand that. Totally. Let's move on because girl totally didn't understand that. So a store prints a request on each receipt asking customers to fill out a satisfaction survey online if they are willing. This is none of the above because it's voluntary. It's voluntary response sample. So we have a voluntary response sample. It's a voluntary response sample, and then we also have a convenience sample to go over. I'm so tired. Okay, a hospital wants to survey religious participants in their city about what they seek from the hospital chaplain. They randomly select 5 religious meetings in the city. Oh, not this again. Okay. It's given cluster. A hospital wants to survey religious participants in their city about what they seek from a hospital chaplain. They randomly select 5 religious meetings in the city and survey every participant in those meetings. I don't know. I just don't understand. I leveled down. How nice of them to tell me. Okay, let's try this again. I literally, like, can't. I can. You know what? No negative things. I can do this. I can do this and I'm gonna do this once. What do you mean I need to refresh? I need to go to sleep. Yes, you're right. I do need to refresh myself. Refresh and go to sleep. What? Okay, you know what? I'm taking this as a sign. Oh no, never mind. I thought it logged me out. Okay, I guess we're continuing. A large company surveys 100 employees by taking random samples of 10 managers and 90 non-manager employees. What is this even, literally? What? This is not a simple random sample because they don't have equal chances of being chosen. Random sample of 10 managers and non-manager employees. Cluster random sampling. Systematic, it's not systematic. Is stratified? Because it's taking like blocks, so it's like separating them by like managers and non-managers and taking, okay, whatever. Anyway, moving on. A manager associated each employee's name with a number. Blue balls without looking to select a sample of 5 employees. So it's a simple random sample, I think. Yeah. Employees at a website want to select a sample of their users to ask for a donation. I love these problems. They randomly, only not these problems, like the questions that they ask, but like website problems. They randomly select one of the first 25 users. So, systematic or convenience. They also show the message to every 25th user. So this is the difference between systematic and convenience. So convenience is, I'm going to choose the first 25 or the first 5 students to enter the classroom or the first 25 users to use my website. But the difference between systematic and convenience is that systematic takes it one step further and takes every K number after that. While convenience just takes like the first blah 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 and that's it. But systematic takes like a certain like pattern, like every K number. Okay. A researcher polls people as they walk by on the street. What in the world? What? How is that even? That's, voluntary response. Convenience sample. Oh, come on. Convenience sample? Right, because it's the first people that they see. But also, like, voluntary response, though. Like, people can... What is this? What is this? No, get out. Okay. A support hotline asks callers to stay on the line after they have completed their call to respond to short survey. What? Yeah. The principal orders t-shirts and wants to check some of them to make sure they were printed properly. She randomly selects 2 out of the 10. No, not this again. I think that's cluster. 2 out of the 10 boxes of shirts and checks every shirt. Oh, systematic? Oh, come on. This is annoying now. A principal? No, it's cluster. Yeah. Checks every shirt in those 2 boxes. So cluster, yeah. So cluster, when you think of cluster, think of like not as representative. Like this is really not as representative if we were to take an SRS of each of the boxes. So I think cluster. That is a good one. A school chooses 3 randomly selected athletes from each of its sports teams to participate in a survey about athletics at the school. Stratified. Because each of the sports teams is a strata. And so from each strata you take a sample. Yeah. Okay, thank God. Can we sleep now? No, you are not sleeping. Oh, did I do this? Types of studies. Oh. Sampling method considerations. What time is it? Okay. A large bakery produces cakes in an assembly line. Sergio noticed a potential defect that seems to be showing in every other cake. He decides that in the next production run, he'll take a random sample of cakes to get a better idea of how many cakes might have this defect. Why might Sergio choose a simple random sample instead of a systematic? Why? How am I supposed to know, man? Just let me be a little. I just want to be sleeping right now. Like, it's not the part. Okay, why might Sergio choose a simple random sample instead of a systematic? Matic? Okay, let's read the problem again. I didn't understand it. A large bakery produces cakes in an assembly line. Sergio noticed a potential defect that seems to be shown in every other cake. He decides that in the next production run, he'll take a random sample of cakes to get a better idea. A simple random can save time, so there's less volumes, blah blah blah. A simple random sample guarantees that Sergio will get some cakes from each hour production. If the effect is in every other cake, the random sample can be completely depending on what Sergio chooses. Exactly, duh. Okay. A college professor wants to survey a sample of students taking his course. Here are some details about his course. He teaches 5 sections of the course. There are 250 total students across those sections. Oh. There are 50 graduate students and 200 undergraduate students. Oh, Jesus. Oh my God. Each section has about 50 students, some graduate and some undergraduate. Oh my God, I'm gonna cry. The professor wants to take... I'm not gonna cry. Okay. The professor wants to take a sample of 30 students for a survey. He suspects that opinions on the survey may differ. Oh my God. Oh my God. Based on student type? What? So he wants to design his sample to take them into account. Okay, based on student type. So, undergraduate versus graduate. So, this is horrifying. Okay, so let's try to do this by ourselves. Here. Okay. So Kyle wants to survey. So he wants 30 students. Or we have a population. So we start off with a population of like students. And he basically wants them into blocks. So he wants students and then he wants... Okay, so I get it. Hold on. So 250 students. And then he wants them into blocks of undergraduate, of student type. So graduate or undergraduate. Graduate or undergraduate. What am I saying? Graduate or undergraduate? Okay. Okay. So this is group 1, group 2, and then each is going to be given what? This is not an experiment. I'm so confused because it's not assigning, it's not a treat. What? Oh, this is sampling methods, not experiment. Okay, see, this is what we're not gonna do. Okay, oh, I think, okay, here's the thing. This is the part that we're trying to talk about. How are we randomly assigning? This random assignment, how are we randomly assigning them? Oh wait, it doesn't make sense. You're not randomly assigning. Yeah, this doesn't make sense. This is randomly selecting. This is sampling. No, yeah, that's exactly what I mean. Random assign. You know what? At this point, whatever. Okay, randomly select 6 students from each section. But like, right, so 30 students. Graduate students and 24 undergraduate students. Oh, I remember this question. I had to do like a ratio type of thing. Oh no. For each student, randomly select one of the first 8. Not that. Six students for undergraduate students because there's more undergraduate students than there are graduate students. Okay. A concert venue offers tickets in 3 zones. Tickets in the orchestra zone are more expensive and tickets in the balcony zone are less expensive. Managers of any wanted to I remember this question. Managers of any want to survey approximately 150 guests at an upcoming concert about their overall experience. To take a systematic random which strategies will accomplish their intended design. So there's 3 zones, and they want to take a systematic random sample of the 3,000 guests they expect to attend. So what I would do is I would make sure that I get a sample of those 3 zones. The management want to survey approximately 150 guests at an upcoming concert about their overall experience. So in order to do that, they wanted 3,000 guests expect to attend. One of the first 20 randomly select a row and invite every guest in hour to participate in the survey. Randomly select 50 tickets from each zone and invite those guests to participate in the survey. Music computer instrument. No, you don't want to do this because it doesn't take into account every zone, because every zone could be a confounding variable. So E. Nope. Great. Nope. Great. Oh, they said they wanted to take a systematic random sample. This is so annoying. Randomly select a row, randomly select one of the first 20 guests to arrive, and every 20th guest thereafter to take the survey. Randomly select a row and invite every guest in that row to put in the survey. Change randomly select rows so get into the row you know. I guess this way. Since the guests arrive in some order. I guess. An airline offers a certain flight once per day that usually contains about 250 passengers. The flight offers seats in first class, business class, and economy class. The airline wants to survey 500 passengers This slide about the overall satisfaction of the passengers will be selected using a cluster random sample. Not this again. Where each flight is a cluster. I need to breathe. Okay. The flight offers seats in the first class. What does this even mean? I can't even comprehend. It's so, I can't even right now. My brain is like fried. Okay, why is a cluster random sample better than a simple random sample? I don't know. I literally do not know. Okay, an airline offers a certain flight once per day that usually contains about 250 passengers. The flight offers seats in first class, blah blah blah. What's the point? Once the survey finds results about their overall satisfaction. Because we don't really want... Oh, this is so annoying. A cluster sample chooses some passengers from each flight, so the airline will be more likely to get a representative sample. You're joking. I'm literally done. That's so annoying. A cluster sample wouldn't select some passengers from each flight. That sounds more like a stratified sample, and it brings result not representing a sample, for instance, too few first class passengers. Oh, come on. I'm literally done with this. Can we move on? Okay, so I'm gonna just write this. Sampling. Oh, for the love of Jesus. Can't even write. Oh my god. I can't. I can. What do you mean, Sarai? Stay positive. Sampling method considerations. I can't wait for Saturday so I could just sleep. Sampling method considerations, Khan Academy, go back to it, hashtag reminder. Okay, anyway, I think we're gonna go not to sleep because I still have web development and data science and Blender to do, so that's great. So we're just gonna take a little break. I already did web development at school today, I just have to finish it. Let's see if I have it open. I'm gonna delete all of these tabs. Might as well turn this into a day in the life of, or the afternoon in the life of Sarai Monte. Instead of like, study with me for stat. I'm not even logged in. How rude is that? Okay, what is it? CodePen. Not me still eating my chocolate bunny. I hate this picture. Let's pick another one. Yeah, this is turning into a day, well, not a day, night in my life. That's so beautiful. Copy the address. This is the background image for the first one. I don't like it. I don't like it. It's giving very blurry. I think. This one is really beautiful. Sneak peek into what Sarai does. Okay, and we're gonna do background position top. And we're not gonna do right. We're gonna do top center. How about that? Top center. I think that's fine. I don't like it. Actually, let's just do center. I don't know. Why is it all so ugly? Why is it so blurry too? I don't like it. Let's do border radius. I tried something new today. I tried literally using Word as my layout for my entire web page. I haven't done that before. It's very exciting. Okay, see, now there's a border layer radius, border radius, right? You could do like font size 30. Am I liking this? Turn down that ratio. I like it. I like it. Better. Okay. Let's see. We can do like box 1. We can do like linear gradient and do like RGBA 77, 0.7. Close that. RGBA 77, 0.7. Let's see if that works. That never works, literally. Every single time I try, it never works. It's so mean. So good. Disrespectful, literally. Okay, anyway. Okay, we have that. It just looks so absolutely ugly. I mean, do we really need it to be that big? Oh, for the love of God, that's not what I want. I don't like it. Let's move this to the top. It's giving horrifying. Whoops, no, that's not what I meant. Let's do 3. Sure. Okay, and then let's move box 2. Where is it? I think it was what? 4? No, so 4 to 9. This is the most horrifying website I've ever done in my life. Okay, let's try to get rid of that border. Box 1. What? I mean the container. Okay. And get rid of that color for box 2. Let's do this white. Oh my god, it's horrifying. And let's get rid of that color for box. Okay, first of all, we really need a new picture. This is just so ugly, like I can't even stand it. This is really beautiful. This is really beautiful. We can change those pictures at the bottom. The thumbnail. Where's the thumbnail? Okay, here's. Oh, see? Much better. Now let's find a better picture for the top. Let's change the title. Look. Your endless journey today. It was literally so ugly, but it's fine. Okay. See, we love this. It's so pretty. Maybe what we can do is we can move the image, right? See what I'm gonna do? See what I'm gonna do? Hold up. I'm gonna fix this. Ready? Left 25%. Okay. And then save that. See what it looks like now. Okay, that looks even horrifyingly worse. Okay, what if we do? Okay, 35. It looks fine on this screen, but it's so bad on the real one. Okay, I think it's 30 that we need to do. See, perfect. And then a little bit more to the top, so let's make that 35. Okay, well, that looks finer, I guess, or whatever. And then maybe I could take this color, excuse you, and use that as a background for box 2. Sure. And then we can do like, did I give a class? I gave a class to, right? I gave a class to, wait, yeah, I gave a class, right? Okay, good. So I gave a class dot item. I can do color, everything in there. Don't forget the hex. Oh, that's not what I meant. That's so ugly, it hurts my feelings. Okay, let's try this like yellow color. Oh my god, you know what, it's okay, we're practicing, we don't need to make this perfect, we could look like a 2000 website, it's fine. Let's see. The footer is giving ugly. Okay. Footer is box 3 then. Interesting. So I need to move all the way to 10. Perfect. See how we do that? How about I do 10? Go to 11. And this one starts at 11 and ends at 12, even though there's only 10 rows. Oh, but then we can't see it. It's okay. I really don't care about it. We can have the footer, right? Where's the footer? I lost the footer. Oh my god. The footer, and give it a padding of what, 1 EM? See, that's fine. Okay. There we go. See, a decent website. Oh, for the love of God. This is what I get. This is ridiculous. I have to fix everything. Wait, I said, what did I say? This is just not fair. This is not fair. It's 10, Sarai. So smart. Or maybe 10, 10, right? Can you please just fix yourself? Oh my god. 10, 10, and then this one. Or box 2. Oh my god, this is so annoying. What if I just do like 11? Like, oh, this is just annoying me. Like, this is literally just annoying. How about we just do like top? Oh, for the love of God. Okay, let's do center, but from the center, like what, 10 pixels? 50. 5. 5. Like, what more do you want from my life? 5 pixels? I really need to go down. Oh, for the love of God. Okay, let's do 15. I'm gonna cry. No. 10? Like, what do you want from it? I'll turn it off. Negative 10 pixels. How about that? Are you happy? Negative 50. Okay, at this point it's done. It's over. I'm literally over. Why does this have to be so difficult? I don't understand. See, was that so hard? I just don't like the look of this. You know what I'm gonna do? I think this is fine. I just feel like it's really ugly. Okay, this is as good as it's gonna get. I literally don't even have the patience to do anything else. Okay, so we're just gonna put that in. What in the world do I do? I just want to sleep. I just want to sleep so bad. Wait, that was result or code? Oh, come on. Okay, that was the result, so. And then what's the code? The patience. Screenshot. I would have added a button where it said book your endless journey, but I have no time right now. I've been going to sleep at like literally, I have been slacking so bad. Like I've been going to sleep at freaking 2 a.m. Oh, sorry, 2 a.m. like 1 a.m. midnight the last 2 weeks, and it's been amazingly well. I can't say it's been horrible to my productivity, but it's been horrible to my health. But it's fine. It's fine. Spring break is coming and we'll be able to live. I usually do a video, but it's not even responsive. Did I do? Oh my god, I didn't even make it responsive, did I? I didn't make it responsive. Oh, it's okay. I can do that real quick. Hold on. You go down here at media, max width 800 pixels, and when that happens I want the container, I want the grid template columns to just have two. And I'm just gonna copy this and just change it to 600 pixels and have it be one column. So now if I do this, that's the wrong thing. If I do this, hurry up, man. I save it. Oops. Box 2. Okay, can we see it now, please? Okay. We love absolutely not doing what we just said to do. Like, are you kidding me? I'm this close to just crying now. I mean, did I really say that? Sorry. I did not mean that. Grid template. Is it not box 2? It is box 2. Oh, it's hashtag box 2. Because it's an ID. I give it an ID. But, see if it works. Yeah, it works. Now I just need to fix the things that I do. The background position, I need it to be top. Oh wait, no, but that's for thumbnail. Okay, at this point, man, I just give up, man. Like, this is so annoying. I don't even want to do. Okay, you know what? Forget it. I'm done. I'm so tired. Okay, whatever. It doesn't matter. It still works though. Just have to reload. See? Okay, perfect. Moving on. Okay, so that's today. Let's go to Blender. Okay. So, Blender, today is day 56. Let's open it up. Okay, so let's do general. So I'm gonna try to practice that curve thing again. So let's delete this, Shift A, go to curve, add Bezier code, whatever. Bezier curve, not code, sorry. Oh my god, I don't have my mouse. Oh, let me delete this. Delete it? I mean, what am I saying? I meant remove. What is wrong with me, like, actually? Oh my god, I've been at this for 4 hours. Okay, Shift A, Bezier code or whatever. Code, why do I keep saying code? I mean curve. Okay, we're gonna go to tab and we are going to just, I don't know, man, we're gonna figure things out. We're just gonna move things. Just make sure we can move this way. Why does it do that? Why does it stay in the bottom? I didn't do 2 curves. Did I do 2 curves? I didn't mean to. Okay. So, Great. So let's do mesh. Can I move this to be here? Right, just so it could be the origin. And I'll do Shift A and we'll do like a cylinder. Scale that down. Or could we have done it? We could have scaled it with. Scale it down. Okay. We're gonna turn on X-ray. We're gonna do this. Ready? Select the whole thing. We're gonna do Control R for some loops. Increase it with our mouse. Oh my god! I don't even have. Wait! Out! Out! Get out! Out! Okay. Let me turn this on. Okay. Now, Control R, and we're gonna increase. We're gonna do. Actually, can we have just done 4? We could have literally done 4. No, let's just do 2. And then we're just gonna move it up. We're gonna move it up. And we're gonna do Control R again. We're gonna do 2. We're gonna move it up. Right there. And we're gonna do Control R again. And we're gonna do 2. We're gonna move it down. Right there. And we're gonna do Control R again. And we're gonna do 2. Move it up. Right there. In the middle. Thank you. So now, something like that, right? So what I'm gonna do is I'm gonna take these ones in the middle and I'm just going to scale it inwards. Why does it scale like that though? I don't like that. I don't like that it scales that way. I want the whole thing. No, that's horrifying. That's not what I meant. Like, no. No. See, that's also not what I meant. We'll go with it. Okay. And then, I can't even tell what's what. I made such a mess. Okay, inset. Right, and then scale. We'll go with it, man. I literally can't care right now. So this is what it looks like. Oh, we love making horrifying messes. Like, why can't I do anything right? Okay, let's select this again. Maybe this time will be good. See, it's not giving right now. It's literally, okay, how about we do tab? No, not tab. From you. Okay. Okay, so see, if we just do this, see, we can be smart about it. Okay, really? Really? I don't understand why it has to be so. What is wrong with this thing? Why is it only taking. I'm so confused. I'm literally fine. I'm fine. Front view. Can you just please stop? Tab. Maybe it's these. Maybe it's that. Are you kidding me now? Okay, we're gonna go with this because girl has no time. I literally don't even care. Okay. Oh wow, look, it does look fine. Shade smooth, and now what is that? Literally, what is? I don't even care at this point. Okay, add a modifier. We're gonna add a bevel modifier so it looks nice and sharp. We're gonna click on. We're gonna add a few segments so it looks even nicer. Isn't that beautiful? Okay, and then I'm gonna add a material. I'm just gonna add a color because I don't have any silver material and I don't feel like downloading it because it takes several hours. Actually, let's do that because I want to actually do something cool today. So let's go to ambient CG. Let's go to materials. Material color. I want to blue. Okay, silver. Okay, first of all, really, do we really have to be like this? Oh, I like this. Nuts and bolts. Nuts and bolts. Okay, let's download 2K PNG. And then wait 5 seconds. Open that up. Close this. It should open up. Okay. Nope. Out. Get out. Get out. I literally said to get out. Okay. Nope, that's not what I meant. Go to desktop. Go to desktop, right? new folder, hurry up, new folder, folder, silver. And we're just gonna put, oh my god. Now, wait, everything's a mess. Okay, I'm pretty sure this is it. I'm not even gonna bother putting it in my Blender folder because I do not have time. Okay, go to shading. Okay, select this thing, Control-Shift-T, go to desktop, get that silver. Where is it? Where is it? Okay, silver, and just select everything, and then do that. And then, oh my god, what if it freezes? I haven't saved my project. This is ridiculous. Okay, any day now. Oh, okay. Just save my project as Bolt. Oh my god, I love the movie Bolt. I love that movie. Let's just go here. Okay, so as you can see, it's like that, but the color's a little weird, so we're gonna change it to be a little darker. See, Sarai likes that better. Okay, okay, back to layout. Let's turn this on so you can see how pretty it is. Okay, so now we're gonna go to modifiers, and we are going to add another modifier. And this modifier is going to be the array modifier, and so what that's going to do is going to multiply the thing, and we can say, okay, we want like, oh no, okay, let's say we want like 10. Okay, really, hurry up, I need to know. Now it's frozen. Great. Oh my god. I'm so tired. Okay, any day now. Any day now. Any day now. Okay, see, I didn't say 75 though. 10. Let's say 10, right? Oh my god. Okay, so here we have 10. So what this does, it makes multiple copies of the mesh. So if I want, let's say 20 screws, then it'll give me 20 screws, and it'll fit that count. Now the relative offset, I want it in the z-axis, not the 0. So I want the space going to like up, not down, and we want to make that x 0 as well. So hold on, 0. And then make this one so that it's spaced upwards. And we should see that any moment now. Okay, perfect. See, great. Anyway. And so now you can see it's very, very nice. It's so beautiful. It's so nice. Okay, and then see, oh my god, sorry. See the things we could do with practice and God. Okay. But I don't want it to just fit to the count. I want it to fit on the length of that curve. And so I'm gonna just do that, right? So now, see, can you please hurry up? What is wrong with this thing? Okay, now it's gonna fit the length of the curve. It's gonna have enough to fit the length of the curve, but the reason it's not applying to the curve is because we haven't added a curve modifier. So what that's gonna do is going to make sure that it goes top of it, like it's gonna fit along the curve. Oh, for the love of God. Deform axes Z, and it's probably gonna now be disformed. Oh, never mind, it's not gonna be deformed. For once, it's working. Jesus, for the love of God, thank you, Lord. Oh my God, I'm so happy. See, it didn't work last time, but apparently it wants to work now. I don't even know what I did wrong last time. Oh, I think it's because I didn't have the thing in the origin. That's why I was deforming. Anyway, you wouldn't know what I'm talking about. But yeah, isn't this beautiful? Isn't this beautiful? Like, this is amazing. Oh, now it's frozen. Oh, for the love of God, that's not what I said to do. I'm so tired. And you know what? Just to add some fun, let's change the color to something unusual, controversial. You know, if it wants to ever move. Let me just save the project so it doesn't delete itself like it always does. Why aren't you moving? Oh, it was already there. Call me smart in 5,000 different ways. Because literally, or blind. Call me smart or blind. Like absolutely blind. I don't like light colors. Make it do red. Oh. Green? I like green. It's giving sewer vibes. Okay, and maybe we can go here, right? Modifiers, and maybe if I just add like 2 spaces. Yeah. Oh my god! Stop it! Stop it! I just got 5,000 ideas of what I could do. This could be like the Chinese lanterns type of things, like the Chinese, the way they decorate, they have their decorations, like their lanterns. Oh my god! Stop it! Or like one of those can things, like those. Oh my god! I have ideas. I have literal amazing ideas. Okay, I'm so excited. This is so exciting. Oh my god! Stop it! Oh my god! Not me thinking of building apocalyptic scenes. Apocalyptic. Can I even say it? Can I even say it? Can I even pronounce it? Okay. But if I go to edit mode. Very nice. If I go to edit mode, right? And I just make a change to one of the things. So like let's say like this one. Excuse you, disrespectful. I can inset it, right? And I can extrude it. Why aren't you moving? See, that's not what I meant. That's literally not what I meant. Oh my god, you make one mistake and it takes 5,000 hours for it to actually move. Okay, let's make sure X-ray is on. Okay, so then you would extrude it on the Y. Oh, for the love of God, that's not what I meant. Yeah, here, this is what I meant, yeah. Right there, sir. So now you can see that there's a hole for each. Where is it? Oh, it's right here. So you can see that there's a hole now in each of the copies of the meshes. Where can I point it out? Right here. Like, this is a hole, this is a hole, this is a hole, another hole. Isn't that amazing? That's crazy. Look, I made my first tube, my first plumbing tube. That's amazing. That's great. Oh my god, literally beautiful. Or a snake, you consider this a snake too. Anyway, let's, I'm just gonna take a screenshot of this because I do not feel like rendering a piece of tube. That is absolutely useless and no need to do that to my computer. So we're just gonna screenshot. Oh my god, I can't believe I spent like 6 hours a day doing stuff. Okay. Okay, hurry up. Sarah wants to sleep. Oh my god, I'm gonna cry. I'm not gonna cry. I'm not. Why did I say that? You did not catch me saying that. Okay, save. Delete. Okay, get out. So I'm gonna say grading of 2. Blend, what do we call it? Bolt? Nope, bolt. Task. Applying material, modeling. Ooh. Curve. What do we do? Arrays, array modifier. We did a curve modifier. No. Well, yeah, we did extruding, we did scaling, we also did inset. And then we also over here we did apply material, right? Title. What did we do? What did we title it? Curve. Fitting object to curve. Part 2. It's just practice, and then change cover to whatever this is. Same thing over here. Choose image. Oh my god, I need to go to sleep. 12:24. Okay, it's fine. We're on good timing. And then yeah, that's pretty much all. Oh, I haven't done data science. Literally, cry me a river right now. I can't do this anymore. Yes, I can. Sorry, be quiet. Oh my god. I just want to sleep. I'm gonna cry. I'm not gonna cry. Why do I keep saying that? I'm so sorry. Okay. Filter. Day. Today. Save. Filter. Day. Today. Save. Filter. Day. Today. Save. Material we used, I have it somewhere. We added a material. Wait, open it. Okay, the link is this. It's metal plates. I used it for bolts. And we could definitely save image as, and then just so I know what material I used. And no, oh my god, I'm crying. Upload image. Okay. Delete. Oh, I forgot to, okay. Copy, delete. That's data science, so let me load that there. And while that's loading, I'm gonna go to life. Close this down. Web development. Go to the first one. That's not the first one. If it didn't save, we're gonna have a problem. Okay, here, thank God. Okay. I forgot to do materials. So filter, day, today, save for everyone, new. I'm gonna put the link there. You don't even need to do anything, just put the link. Filter, day, today, save for everyone. Why is it highlighting? Filter, day, today, save for everyone. Didn't use tutorial, great, that's fine. Let's get out of here, move this down. Today is day 261, April 5th, 2022. It is a Tuesday, and it is week, oh, I forgot to change the week. This is week 39. Week 39. We are going to create a data frame because Sarai has no time. Like, this entire week, I have not been dedicated to data science at all. So, we're gonna say sample 1, 2, 3, 4, 5. Okay. Oh, for the love of God. And then we're gonna do, what is it? What are we doing? Sample method. We're gonna do, like for sample 1, we did a stratified, just stratified, and then we're gonna do a simple random sample, or let's just do an SRS. This one we did a clustered. Here, cluster. Here we did a voluntary. Oh, for the love of God, whatever. Convenience. I probably spelled that wrong. Convenience. See, yes I did, of course I did. Okay, convenience. Spelling is not my strong suit, like, at all. Convenience sample. How many more? Do we have one more? Okay. And then what's another one? Voluntary. I don't even know. Let's try sample. Let's try systematic. Okay. Data. Okay, so sample method, perfect. Now let's go to sleep. I literally do not have time for anything. Okay, that's today's video. Bye.